Hey everybody, and welcome to Into the Terminal. Today we're going to be talking about bash scripting. And let's jump on into the terminal, and we'll start off with some handy one-liner commands that we can build as scripts. So one of the ones I use all the time is to find where large files are or where a lot of files are, especially when my server or desktop is close to being disk full. So let me just show you. I use du, and then you can give du a specific directory, and it'll do every subdirectory recursively throughout this chain. So by starting it off at /, it'll actually look over the entire system. But if it was my personal system, I'd probably look in like my home directory as the starting location. So it'll tell me where all those files are stored. So it goes through and it shows me all the files. And we can instead sort them. So instead of getting just all the files as we find them, instead sort will order things. And I pass two arguments, R and N. I want it to do a reverse sort. So show me the biggest things first, because by default, it'll show you the smallest things first. And then an N says, treat this thing as a number. By default, sort will do a character comparison. So because the thing I want to sort on is that first column, which is numeric, that's what the N flag tells sort to do. All right, so there we go. There's all the stuff on my system. But notice it scrolled by really quickly. So we could do another pipe to maybe look at it one page full at a time. But because we're looking for big files, I just like to send that to the head command, which shows you the top portion of something. And I'll limit it further and say, only give me the top 20 lines. -n is the number of lines that you want head to show you. And so here we go. These are the top most used places where files reside, or the biggest directories where files reside. And so one of the weird things is that everything rolls up to /, so of course that's first. And then var has a directory underneath of it, which is var log. So really, var logs files also count against var, which also count against /. So there's a little bit of reading that has to go on here. But if we look in var log, which is our third largest location of files, what we can see is one file is bigger than all the others.
Really conveniently named too.
Exactly. As no. So we can remove it. And then when I rerun my same du sort with top 20, what we'll notice is that var isn't in that top section anymore because it has fewer files. The files are using less storage, essentially. So I use this all the time for like, my file system is close to full. Let's see where those files are, and are there any I can delete to free up some disk space back again.
And there's a really handy flag for du. I just want to mention this because it saves some of that parsing, right? That'll tell it how deep to go. So you could say only go depth 1, and then it'll show you in the current directory what each subdirectory consumes. And then you're like, oh, var is the big one. Go into var and do the same thing. And then it'll show you subdirectories there, and you can sort through and say, you can kind of follow the trail that way. Sometimes it's a little easier than showing everything.
Yeah, but what we're demonstrating is that like in that one line of command, right, we actually ran several commands and hooked them together with pipes to take the output from one into the input of the next, and take the output of that one after we make some changes to it, and take it to the input of the next, where we can make even further changes or maybe look at only a subset. So this is at a very basic level shell scripting. Nate, you had another example that's pretty common to use too.
Yeah. So something I did pretty frequently as a systems administrator is parsing logs, right? And parsing logs can sometimes be a bit of a nightmare. So I've got a log file on my demo system here, just called error log. And this is legitimately the error log from one of my websites. If we just look at it, we can see that it's pretty lengthy. This is just like today's log. We can do like pipe it through word count -L tells how many lines it is. There's almost 1,500 lines in this thing. Hard to just read through, right? Also, you see that scrolled off the screen. There's a nice tool called less. I forget if you had touched on this already, Scott, but if we just do less on the error log, it'll let us scroll through it, kind of line by line here. But again, not all that helpful. But you can see if we look back at like tail or something. Here, let's just cat it again. There's a lot of errors that look like this file not found error. Let me just find an example of one. Here we go. No such file or directory, right? Obviously, no such file or directory just means that someone's probably trying to crawl the website, looking for files that should exist but don't, or they think might exist. Sometimes that's indicative of a problem. Sometimes it's somebody trying to poke around where they're not supposed to. Sometimes it's just search engines doing their thing, right? But so this maybe isn't the best example of why you'd want to look for data in a log file, but it's a great example of how to get the data. So I'm going to kind of hone in on this particular error and give you some tricks on how you can just like pull out, say, who did this, who made the request, right? Because you can see each line tells me like what file, it tells me what website they accessed, and it gives me the IP address of the requester, which is in here somewhere. A lot of times what you're going to want to look for is, you see how there's these numbers here? Sometimes these are error numbers from whatever generated this, and you can just grep for the error number instead of having to grep for a text string, which is what I'm about to do. In this case, the error number is not always the same, so we're going to have to play it with the text string. So what we're going to do is, I've got a crazy thing here I'm going to paste in and tell you what's going on here. We're going to use grep. We're going to look for this no such file or directory error message that we see all over the error logs. Then we're going to pipe it back into grep. And we're going to tell it to look for an expression. And it's going to use this crazy regex. Now, if you're not familiar with regular expressions, or even if you are familiar with regular expressions and you don't fully understand what that is, I'm going to tell you what it is. And I'm going to tell you why we're not going to delve into the regular expression. I searched Google to find it, because typing this out and figuring it out, I would have had to have spent all week, I think, trying to get this just right. What this is doing is it's looking for IP addresses, right? Or numbers that are formatted like IP addresses, because it doesn't know if it's really an IP address or not. So we're going to throw that in there, and you can see, sure enough, it's got all the IP addresses, right? That were from that log that matched that text string. But it's still not terribly useful, because you see a bunch of these are repeated, right? And it might be really handy to try to parse out someone who might be a bad actor to see how many occurrences of each IP address we have. I'm going to skip one of my things here, and I'll just explain it. Just give me a second here. Copy and paste. All right, so we're going to add two things that we're going to continue to chain our output through. First, we're going to sort it. And the reason we're sorting it is because the next thing we're going to pipe through, which is uniq, which looks for unique flags, needs them all kind of in blocks, right? So it would group, say, this block of IP addresses, but not, it wouldn't then other instances of that IP address also block in, right? So you have to sort it first.
Hey, Nate, why don't we just run it with sort? And then we'll
sure, we can do that. And that was how I was going to do it at first, but I was trying to save time.
It may be helpful to also clear your screen so that we get the command up at the top. Whoa, hey there, you go with camera.
I mean, clearing the screen didn't help that much, unless you want to see the command. All right, here, let's clear and then show you the command. So we're just putting the same thing through sort, and here it is. Now it's grouped all the IP addresses together. See, like this 219 address is all in one block. This 192 address is all in one block. This 46 address is all in one block. And now if we clear it again and add in uniq, what it would do is just deduplicate it, right? You can see now all those IPs that were duplicated are just single lists now. But if we add the -C option, this tells us how many occurrences of each address showed up, right? And you can see this one's here 14 times. This one's here 27 times, right? But this list still isn't great because look here, 97, which might be indicative of a problem, is way up here, like off the top of my screen. I'd have to then parse through and see what's what. So we're going to now add in sort again, which sounds repetitive, but we're using sort again for a different purpose. We're going to sort it again with the -n option that Scott used earlier, except I'm not going to reverse it because I want the big ones to show up at the bottom because that's what's going to be on the screen. And here, let me let you guys see these a little bit better. Right? So sort -n tells it to sort it numerically. If I added the -r, then the big ones would be at the top. In this case, they're going to be at the bottom. And you can see my 97 is all the way at the bottom. So that one shows up right there in front of me, which is helpful. And I can also see that, you know, the vast majorities are like 1 or 2 hits, right? A bunch of 1s, then some 2s and 3s. But, you know, these might be either someone trying to beat up my site, try to find stuff they're not supposed to, or it might just be Google, you know, indexing my site and looking for stuff that it knows might be there. It wants to see if they are.
So I do have a couple of quick notes. One is regexes. Man, okay. I'm sure everybody looked at regex and went, holy cow, how does one make that thing? So one is you can spend hours, like some people, learning how to make really complicated regexes, which is short for regular expressions. Or you can look for examples and other stuff of people who have already made those regular expressions. You just copy paste. And Nate, that's what you chose to do, right? Because more efficient.
Yeah.
Time.
Yeah, exactly. I did a quick, in fact, it wasn't even Google, it was DuckDuckGo. And it even came up with, in one of those little sidebars, it just said, this is the regex you want. So it's apparently common enough that they've got this stored somewhere, cached. But yeah, I did find a nice article that explained several ways you could get IP addresses. And this was the regex I decided to copy out of somebody else's work.
Yeah. And the other thing with regular expressions is you can spend a lot of time crafting a extremely explicit regular expression that only matches the exact things that you're looking for. Or with a lot less time and trial and error, you can get something that's pretty darn close and then use tools like sort or cut.
Yeah.
Or a second grep to like weed the things that you don't need.
I'm going to be totally honest. Normally, what I would do, because I wouldn't deal with that regular expression, I would make a command line with all the chaining and whatnot that I needed to take that line from the error and use like awk to chop out the IP address. And then that's what I would display to the screen. Right. And then I would do the same thing with sort and unique and all that stuff to get the data out of it. But then I thought there must be a better way with regular expressions because you can like do anything with a regular expression, I think. So I looked it up and thought it'd be fun for today's example.
But there gets to a point where, you know, one-liners get too long and you certainly don't want to type them. So Vincent in chat actually said something earlier about having an alias. And that's a fantastic thing to do because then you can have a hand thing that actually runs this big, long, gross thing that you've made and you don't have to type it every time.
Right.
But another approach is if this is something you use all the time, you might want to actually make it nicer or have additional functionality that isn't really something easily introduced into a typed giant one-liner.
Right.
And so when you're in that state, what do you do, Nate?
So, I mean, any command that you throw into the command line could be thrown into a script. And if we hop back into the terminal, I can show you quick the super basic rendition of turning this thing into a script. So we're going to open up a new file. We're just going to call it ips.sh. And then we're going to paste in this thing, which is basically the exact same thing we just did on the command line, except I added a shebang bin bash to the beginning of it, which tells our interpreter, or I should say it tells bash or whatever you're running it from, what interpreter to parse this with. If you were using Python, you'd use a different one. If you were using SH or CSH, you'd put that in there. This is a bash script, so it's bin bash. And you can see it's the exact same command we just did. We're going to save this, and then we're going to chmod it +X. If you watched a couple episodes ago, we talked all about what I'm doing here. You can go check that out if you want to learn about file systems permissions. We're going to call it, you know, just chmod plus x, make it executable, and then we're going to run it. And look at that. It gives us the same output that we just did in our one-liner. And now it's repeatable, right? If we ever want to do it again, you just run the shell script.
But we can do more with shell scripts, right? That didn't get us any additional features or benefits, right? We could have done that on the command line. So what would we do that would make it even fancier?
So to make it fancier, we're going to have to, you know what, let me copy it to, well, I'll just do it in place. So we've got, you know, the crazy shell script. We've got the crazy regular expression in there. That's kind of hard. It's kind of hard to read on the fly. It's also, you could get into a situation where if you're trying to change that regular expression with it in line like that, you can sometimes end up accidentally changing some syntax that breaks the script. I don't know how many times you've been in there, you change a quote or a double quote, and then it's like, oh, where was that closed? Oh, I deleted too many characters. What was it? Sure, you can back out of those things, but I always find it easier to take complicated things like that and put them into an environment variable instead. There's already an insert mode. So let's go, we're just going to call it regex. We're going to enclose it in single quotes because this tells it to ignore any bash interpolation that it would be doing here, interpretation that it would be doing. Just kind of paste it right up here. And we're going to close it in a single quote.
Want to make a note about that variable. So originally when we were putting this together, Nate used caps because I think if you look at the variables that are set in your environment using the set command or something else, variables are in caps. So like, why wouldn't you use them in caps here? And I will tell you that I always use lowercase variables or mixed case variables when writing scripts. And the reason is because I know that environment variables are all caps. So if I do something like term or path, it's going to overwrite the environment variable of the same name. But if I use lowercase, there is never a worry of conflict between what I'm doing in my script with setting and changing variables and what may be in the shell environment that may be used by the system or shell interpreter.
That's a valid point. I never really thought of it that way. I usually make them capital so they stand out in the command line, you know, just personal preference. But that's a pretty good point there, Scott. All right, so what we did is we put the regex into a variable, and then we put the variable where the regex used to be. And I put it in these curly braces because that treats the variable a little more. I'm having trouble coming up with the word.
It defines the variable explicitly. So if there was surrounding text, it wouldn't blend in the variable name with the surrounding text. It isolates it and says, this is the variable reference I'm doing. We probably, in this example, we could have done just $regex and it would have been fine. Yeah. But using this curly brace offset is a good habit to get into.
Yep. So let's save this and then let's just make sure it still works. Right. And there you go. We still have the same output. But again, we made the script a little easier to read, but we still haven't really extended its functionality at all. So what I really like to do with scripts like this is make it so that this file name that we're parsing is not hard-coded, right? So right now, every time I run the script, it's going to look for a file called errorlog in the directory that I'm in and try to parse it through this command line, or through this chain of commands. And that's not explicitly all that helpful. So what I want to do here is, first of all, let's tell Vim that that it should not be doing syntax highlighting, because I want to copy and paste this out of my notes instead of typing it all live on the show. So we're going to, first of all, just make a few new lines here. We're going to paste this in. Hopefully copying from my Google Doc didn't break anything here. Then we're going to comment this last one out because we don't need it anymore. Because what we've done here is we took the file name. Now, if you're not familiar with this, when you invoke a bash script, if you type something after the name of the script, so if I did /ips.txt or .sh and then some word, that word will be thrown into a variable called $1 as the first argument after the name of the script. $0 is the name of the script, just fun fact, right? So if you needed to check if I was ip.sh, I would check if $0 was IP.sh, but of course it is, because that's what we ran. But there are reasons you might want to do that in the future. $1 is the first argument. $2 would be the second argument. $3 the third. So there's this array. I guess it's not an array. They're separate variables. Other interpreters treat them as an array. Bash does not. So what I'm doing here is I check if there is a variable that has data in it called $1, right? So this tells the script, did I type something after ips.sh? If I did not, right, because this returns, let me think, this returns 0 if it is empty and 1 if there's data in it.
So what the return code is going to vary based on the thing. So how about we say
Right.
it returns successfully?
Okay.
Or not successfully.
Right. So if it exists but it's empty, it'll say, hold on, you need to specify a file. Because if I didn't specify a file, then when I get further on and I try to do the grep and everything, there won't be a file name to throw in there, right? And then I check if there's a file named the thing that I typed. And this could be a full path. It could be a local file, like a file in the same directory. It doesn't care. It just literally looks for that path to see if there's a file with that name. And if there is, it'll do our grep stuff on it. It'll search for the no such file or directory inside of the file. It'll throw it through that regex that we still have up there in that variable. It'll do the sort and the unique and all that stuff. And notice where the file name used to be, I now have $1. And I did not put my curly braces around it. I'm sorry. There we go for not being uniform, right? If it did not find a file or the file is not a file, because that's what the -f does. If that's a directory instead of a file, I believe it returns a not success, right? In which case it would say it's not a file or it doesn't exist, right? And then it'll exit the script because it got to the end of the if statement here. All right, so if we save and close this, clear the screen here. If I do ips.sh now with no command line arguments, it should give me an error. You need to specify a file. Okay, so let's just like put in some file. It should say, that's not a file, right? Which is exactly what it did. But if I type in error log, there we go. So now what I did is I took my one-liner and I made it something that I can give it any log file that I want to give it. And anything that matches the format of an IP address should get returned by the script, right? So this could be super useful and reusable in the future. And reusable
So Nate,
good.
If you can go back into your script, there are a couple things in your syntax there that I wanted to mention. Because we're like throwing a lot of people new to shell scripting.
Yes, exactly. I just ran through all that. Sorry.
So Nate introduced a control structure called an if-then-else. So an if-then-else is I'm going to test a condition. And if the condition is successful, I'm going to do something. Else, I'm going to do something different. So, and there's some chatter in chat about like how one would test. So for example, Vincent said, well, I would test whether if the file name is there and then do my stuff. And if the file name is not there, then do an error message. So there is a lot of like how one chooses to logically orient their control structure.
Yeah.
There's no wrong answer. As Larry Wall, who was the original creator of Perl, once said, there's more than one way.
Always.
So, yeah. All right. So we have this control structure that allows us to make decisions, to check a condition and make a decision and decide what branch of code we want to execute based off that decision. The other thing is that thing in square brackets. So that square bracket thing is called a test. And there's actually a command also called test, which does the same thing. So that is the condition that you want to test, that you want to check. So it can be a lot of things. It can be running a command and whether that command is successful or not. And that's actually what we're doing here with -z.
Yeah.
-z is a command. And it returns a success if the thing that it's passed is a 0 length thing. So if there's nothing stored in this variable, it's 0 length, and that is a successful return for -z.
Right.
I think there's another one called -n, which is non-zero, if I remember
That's
correctly.
possible. I had to
So you-
dust off some bash foo to make this script, and this was the first one I came across, and time crunches and all.
yeah, yeah, for sure. And then you can see that we have another test that's the -f if the file exists. There's also a -d to see if it's a directory. There
Hmm.
are tests to see if it's executable or readable. So you can actually check like all different properties. All of these they're actually built into the bash shell. So they're called bash built-ins.
Hmm.
They're actually documented in the bash man page. So if you're interested in finding more of this, you can find it in the bash man page. There's others like equality checking, so equal equal or -eq. There's greater than and less than checking,
Yep, lots
all
of
kinds,
numeric checks like that. Yep.
or string checks also. So
Yeah.
comparison operators, I think is the term to use.
Another thing I wanted to
Hey,
call out quick was how I broke up this line here. I don't know if you had something else you wanted to touch on there, or is that where you're going
ask
next?
you about next.
All right. So the original command was this big chain of things. In fact, you can see it down here, right? It has all these pipes and whatever's, right? And it makes it kind of long and hard to read. So all I did here was there's a special backslash that if you've ever seen anybody that put anything up on a web page to show you bash ever, they almost always use this to make it more readable. And all this does is it breaks the command up into several lines. And my formatting got messed up when I pasted here. Normally, what I would do is, so this is the first line of the command here where I have my cursor. I would take the sub pieces of it and indent them by a couple spaces so that you can tell where you're continuing the command, right? And then once I've moved on to another command, if there was something else I wanted to do, I would then take that back 2 spaces, and that way it's easier to read.
So I have a different approach, Nate. I actually don't like backslashes, and I just put the whole big, long, disgusting command on one line, and then I'll just resize my terminal so I can see it on one line because I'm lazy.
That's another way to approach it. I hated backslashes for a long time, but especially when I started doing examples and demos, I decided to start using it to make things more readable.
And then I think the only other thing that we haven't talked about is echo command. What's echo?
Oh, echo just prints something to the screen, right? So you can have it. You can also have it do something like prompt you for the name of the file. We didn't talk about that either, but we could say echo, what file would you like to grep? And then, or I could have it in the control structure there that says instead of you need to specify a file, I could have it ask you for a file name, echo the thing, and then have it. What does it read? I think is the name of the command we would use for that. It just reads in from the terminal, right? So you could type in error -log. But if you specified one, it would just do the thing instead of asking you.
And echo is the traditional bash built-in for this. There's actually also printf. So if you wanted to do embedded printing or you're from another background like C, where you're more familiar with printf and using it, you can use it in bash too.
Right.
But the big thing is like you're running this command and you have to have the shell or the script has to have a way of communicating data back out to the user while it's running. And so echo is how we put in our programmatically our
Right.
outputs want to be presented to the user.
Every language has one. It's either print or echo, or remember back in the basic days, you could replace print with a question mark, which was always confusing in code later, but it was so much easier to type.
So we do have a question from Vincent
Okay.
about double bracket. So double bracket is a thing, but it's for arithmetic. So if you actually wanted to have the shell do math, that's what double bracket is used for. Today on Into the Terminal, we're going to be doing another shell scripting tutorial with automating tasks. So why don't we jump on into the terminal and we will start our first one. Nate last week in our post notes said something like, if you do it once, do it once. But if you do it twice or more, script it. And that's what we're going to be working on today. So what's something that we can do that we typically will see used pretty often, or a task that we do fairly regularly that we could automate or get better utility out of by using shell scripting? So here's my first one. A long time ago, I worked or I was on a consulting engagement. I worked with somebody who was a ops wizard for Linux. And I don't use that term sparingly. Like he could literally cast spells and summon dragons while doing Linux operations. But one of the things that he incorporated in our operations was before you messed with a file, you ran a command to back up that file. And he called it BKP. And so the first thing we're going to do is we're going to write this BKP script, and I'll show you how to do it because it'll help reduce errors on your operations and systems. All right. So the first thing we're going to do is we're going to edit our file. And I said we are going to call it BKP. So I'm going to open up a file called BKP. And we're going to start off with a hashtag mark bin bash. Also known as the shebang. It tells us what interpreter should be used when interpreting and executing the commands in this file. All right, so what BKP does is it makes a backup copy of a file that's passed to as an argument. So as last week, we talked about positional parameters a little bit, but the first positional parameter is stored in a variable called $1. So the first thing we're going to do is we're going to add a little bit of usage and checking, because if you just run BKP without anything, it should error. So we're going to add an if statement. All right. And an if statement is structured like this. If some condition, then execute a segment of code. If the condition is not met, we should skip over the execution of this code. And there are some other variants that we saw briefly last week, like an else or an else if, where we can build more explicit control structures. So what we're doing is we're testing to see if the argument that is stored in $1 is a file. So -f is a check to see if the thing that's passed, $1, is a file. So if it's a file, we should do everything else, which would mean I have to put my whole rest of my script inside of that then fee construct, which isn't really what we want. What we want is for me to put all the additional logic and everything else later on in the script, but instead I want to check to see if this is not a file. So adding the exclamation point negates the check. So if -f $1 is a file, that would be success. And then we not it, which means it's a failure, and we skip the execution of what's inside of this code branch. But if what we're passed is not a file, then we're going to do something. And we're just going to echo. Right? We're going to print a message to the terminal. And then the other thing that I'm going to do is I'm going to give them a usage diagram. Right? So this is how you should use this command. And the third thing I'm going to do is I'm going to exit the script at this point. If they didn't give me a file, then there's nothing more for me to do. So I should just exit out of this script. And then the number there is a return code. Normally when a command is successful, it returns a 0 to indicate that it was successful. A non-zero tells me it was not successful. And then the actual number can mean things. So if I don't use the return code 5 anywhere else in this command or in the script that I'm writing, if I look at the return code and I see it's a 5, then I know it's because they failed this check. All right. So let's try it out. I will make it executable. And then I'm just going to run BKP with no arguments. Oh, that didn't look right. If not file, then let's try a different one. Let's do Etsy. All right. We pass it a directory. And it says, well, nope, can't work. All right. So we found our first iterative improvement we need to make to our script. If there is no argument passed, it also needs to trip this error path. So what we're going to do is say if it's this or zero length. So if it is either not a file, actually I need to do that differently. That I think. If it's not a file or is zero length, then we should give the error. Let's see if that works. All right, so that works. If we don't pass in anything, let me pass a directory. Cool. And if I just pass it an actual file, it should silently close because all that we have left in there, or all that we have in the script so far, is just checking to see if there is an argument that is a file. Okay, so that seems to be working. If somebody invokes the script incorrectly, they will get an appropriate error message. All right. So, but what if they do invoke it correctly and they give us the file name that they want? So what we're going to do is we're going to create a backup copy of that file. We need to create a backup copy of the file. Well, this is actually pretty challenging because what happens if somebody just uses a local directory file, like we're in the Etsy directory when we said password, versus a full and complete path name of the directory, Etsy password? How do we know where to store the backup and what we should call the backup? So let me go back a little bit before I put in this copy. The copy is going to be the very last thing we're going to do. And I'm going to put in a little bit more structure. So I'm going to create a couple of variables. All right, and I'm going to show you what these variables do. Let me just echo of file and file name. Okay, so there are these two commands, dirname and basename. When you call dirname on something, it'll cut off everything but the final bit of the path, thereby giving you the directory where that thing lives. And basename gives you the last thing on that path or the file name, right? So actually, instead of doing this echo, let me just dirname user bin ls. There we go. So when I do a dirname on user bin df, notice that it gives me everything that's the directory in front of the actual file that I'm interested in. And if I do a basename user bin df, it gives me that last part. All right, so I now know the directory and where it is. If I'm in, let's say user, and I'm referring, let me clear the screen here, and I'm referring to this as dirname bin df, right? Notice that it still behaves correctly, or basename bin df, right? So it takes whatever path I was given and it cuts down to be just the directory location of the end file or the file itself without all the directory stuff. All right, now here's why this is important and why I created those variables. What we're going to do is we're going to store our backed up file inside of a hidden directory inside of where that file lives. So we're going to check if dollar. All right, now there's a bit of magic here because I'm root executing the script, so it can create directories wherever it wants. So if I was trying to make this available for regular people, I probably have to mix in some sudo rules and some other things. All right, so we're going to create a hidden directory called backup inside of wherever this file lives. So if it's an Etsy, there will be a hidden directory called .backup inside of Etsy. And then we're going to copy our backup into that hidden directory. So we're going to copy $1. Whoops. And let me create one more variable up here to make things a little bit easier to read. All right, so when we make our backup, we're going to put it in the directory where we're backing up this file. We're going to put it in this hidden .backup directory. I just set that as a variable, so we're not using it yet. And then I check to make sure the backup directory exists. And then I can go ahead and perform this copy. All right. So I think that'll work. All right, the moment of truth. If I do a bkp etc http conf http.conf, what should have happened is if there is a .backup directory inside of etc http conf, we'll see a file copy in there. If there wasn't already a .backup directory in there, it should be created, and then our file copy should be placed in it. So if I list etc http conf.backup, there it is. That's the backup that I made before I edit this file and change it. But you know, what happens if I sometime later do a BKP again and make another backup copy? It would overwrite this one because they have the same file name. Or maybe somebody else was working on it and they did the same thing and they overwrote my file copy with their file copy. So we're going to go one extra level. And we're going to use some command line foo to make this file name more distinct. What we're going to do is when we make the copy, we're going to put on the user's name that made the copy. And we're going to put a date and time as part of the file extension on this copy. So we're going to use the 4-digit year, the 2-digit month, the 2-digit day, and it could be that we're making multiple copies in a day, so we want to make, again, it unique enough. So we're going to also add in the hour, minute, and second that the BKP command was run. And that still might not be quite exact enough. So we're going to put in also the nanoseconds of the second that gets logged in this file. All right. Okay. And good. All right. So we're going to back up etc http conf http.conf. Cool. No errors. That's good. All right. Ooh, and I have a typo because notice it says Y instead of the actual year. I didn't put a percent in front of it. There we go. Let's try one more time. Okay, so finally we've got it right. This one right here. So we see our name of the file, http.conf. That root was the one that made the backup copy. Here's our ISO formatted date, our hours, minutes, and seconds of time, dot the nanoseconds of time. And so as long as I'm not making one copy in the same nanosecond, it'll make sure that the copies are distinct and different. All right, but there's one more challenge that we got to fix. So right now, this BKP script lives here in root's home directory. Not a great place. And I would say that not only root should make backup copies of configuration files before they edit them, but everyone should. So I'm going to copy that to user local bin. So user local bin should be on people's path environment variable, meaning if they type a command at the command line, it's one of the directories that gets checked for that command. So instead of telling it // it's my current working directory, I can just now use it as a bare command. If I move somewhere else, I could still run bkp because it's found in my command line path directories. All right, and then I can make a backup copy of conf http.conf. Because I changed my directory to be locally working directory path. And when I ls, right, it still works correctly right here. There's my backup copy. And thanks to it being in user local bin, regular people could also do this. Now, if I wanted to allow regular people to make copies of Apache configs in directories that regular people don't have write access to, again, I probably want to mix in some sudo magic. Not only sudo, maybe allow sudoers to have access to the bkp command, which would allow it to run with root privilege, and that would get me around that. All right, so why would we do this? So let's say we edit my configuration file. And you know what? I'm really bad with VI, and I'm coming in here and I'm like, oh, I messed the thing up. Hold on, let me quit without saving. Oh no, I wrote quit it. Oh, it's dead to me. Right? Right? That's it. It's gone. Well, thankfully, here's my backup copy. So I can just restore it back to its initial state before I messed it all up, right? So my friend Chen, the operations wizard, literally like drilled into the whole team. Before you edit a file, any file, you run bkp on the file, and then you edit it. That way, if you mess it up during editing or something weird happens, you have a backup copy. And then anything else that you're doing with the file that you might want to save its state of, you run bkp first, and then you have a backup copy. So that's a tool that one can write to help their operations, to automate those tasks of making sure that we don't mess stuff up in shell scripting. All right, BKP. All right, so that was a little bit long. We will write another script. We will be writing a script that checks for the versions of software that we have, and we'll actually mix in some SSH so we can actually check more than one system with our script. Now is the part of the program where we look at the questions from the audience. If you are a deferred viewer, please feel free to leave your questions in the comments and we'll get back to them. Nate and myself do a pretty good job about answering comments when they come in. So we saw a bunch of stuff there in the critical path, but I think the most critical things are put your commands in the file, do a little flow control, right? We used if statement to do that flow control to like check to make sure the state is what we expect before we did a task. And then the other thing that you may have picked up on is build your lexicon of commands. Basename, Dirname, where the heck did those come from? Well, you figure it out, right? You do some Googling. Hey, here's the task I'm trying to do. And usually there's a command or a command with arguments that will help you get there. And then you add that to the list of commands that you know so that the next time you're writing the script or you need to do that thing, you know it. For example, like I didn't know that printing a file in reverse order was a thing. But tac is the opposite of cat. It prints the file in reverse order. Who knows? But I've used it now a few times in things like automation because it's easier to try and reverse a file and look at it from the bottom up instead of trying to look top down to a certain point and then care about the stuff after that. So you pick up these little like tricks and ways of doing things because you've grown your command vocabulary over time. But don't be too intimidated because we all started with not a lot. I've just got a lot of years under the belt on getting this done. All right, so let me do a quick look on our questions. Oh, I see Shantanu let me know that he's here to make sure that I get corrected anytime I make a mistake, unlike last week where he was not here and I made a mistake and it went uncorrected. Vincent had a really great idea that maybe in addition to the backup copy of the file, you also snap a MD5 sum of the file so your backup hasn't been changed. In fact, the original BKP program that I was kind of loosely reliving or recreating did that. The other thing it had was a restore option. So you could actually go in and restore your command using or your file using BKP instead of having to manually surf and look at it. So there's a lot of like additional changes that you could make to this utility that we just made to make it even nicer and have even more features and do things like account for other weirdnesses, like somebody modifying your backup file by accident. All right. Yeah, and then Shantanu also said that you can use set so that you can actually watch the script execute. Set-o pipe fail lets you pipe it into something and it results in a failure message. We'll actually get to like messaging and a couple other things in this next example. All right, so back into the terminal. For our second example, here's the situation. Hey, we need to make sure that this software that's installed on our machines, or at least on some of the machines, is the right version. How can we do that? And this will have a couple of different iteration of questions, right? One might be for licensing. Hey, what machines have CrowdStrike installed on them and what version? Or it might be vulnerability mitigation. Hey, there was just announced a vulnerability for this package. What machines are susceptible to that vulnerability, right? So you got to go out and figure out what machines are out there that have the vulnerable version of the package. So we're going to write a small program to do that stuff. All right, so let me go back to my home directory. And we're going to make package test. All right, and you may have noticed that when writing a script, I use a programming style that I would call iterative programming, right? I write a little bit at a time, I get out of the editor and I test it. And then I fix any problems that I might find, then I go back in to make my next enhancement or to make the next segment of the script that I know I need to work. And the reason I do this is because if you sit there and you write this big, long, huge, tens, hundreds line script, and then when you're finished, you test it, man, sometimes it's really awful to find that quote that you missed or the closing parenthesis that you missed, or you have multiple mistakes and you get to troubleshoot it. So when I'm doing programming, I do iterative programming. All right, so here's what we're going to do. We're going to pass to the script 2 arguments. The first argument is going to be the package name that we want to check. The second argument is going to be the version string that we're looking for this package. All right, so just like before, actually, we're going to be less nice to do error checking. Let's just say this $1 and target version equal $2. All right, so to keep this a little bit more simple, I'm just going to assume that they invoked it correctly, that the first argument on the command line is the package name they're looking for. The second argument on the command line is the version that they want to have installed on the machines. Now, we could go in just like we did with BKP and do some if-then checking to say, hey, if this argument wasn't passed, what should I do differently? Should I error? Should I change behavior? Should I exit? But we're just going to assume that they're calling it correctly. All right, so let's do RPM-Q $1. Right, so let's query to see what this version or this package is. So we're going to add the execute permission to it. And we're going to check the less package. So I picked this to make our example work here because I happen to know that there is an update available for this machine for the less command. So currently on this machine, it's running less 590-3. But if I do a DNF list updates less 590-4 is available for these machines. What I want to do is I want to survey my machine population to see who has the old version and who has the new version. So we're going to query this for our package, and that'll tell us what version it is. And then we're going to make a choice. So let me go over here to the client real quick. It's nice to have two machines because you can actually work in two windows. Although I guess I could have just used tmux. All right, 590-4. Is that right? .el9 underscore, whoops, el9 underscore 4. Yeah, cool. All right, so let me get out of this real quick and let's take a look at our output. So when I do an RPM-Q less, it tells me the package name and then that, right, the version and release number, and then the architecture. So if I just say if the output of RPMQ equals this, right, that's not going to work very well. Let me go ahead and flesh out my logic a little bit. All right. So what we're looking for is to test to see whether the package I have installed is equal to this version I want. And in fact, I should put it in as an argument. It's already stored in a variable. So if it's equal to the target version that I want, if that's true, the version I have equals the version I want, prints OK. If the version I have isn't the version I want, it prints fail. But this isn't going to work very well. Because that. Oh, and it helps if I pass the right version. Hold on 1 second. 594 EL94. All right. Still doesn't work very well. Because when I did the check, it just looked at this string. Does this string equal this string? No. The second one has a whole bunch more stuff in it, right? It's got the package name, it's got the architecture that it's built for. So of course the two strings aren't equal to one another. So here's where we could do some of the tricks we did last week. So last week we actually strung together a whole bunch of commands with pipes to take a piece of output and then grep to match only a certain amount, or we could use things like sed, which is a stream editor to cut off certain pieces of it, or we could use tools like cut to chop up our output and then only select certain bits. So you could do it that way, and that would be perfectly fine. But I happen to know through my command lexicon of building over the last 25 years that the RPM command can actually customize the output that it provides to be something different than what is shown here on the screen that I've got highlighted. Instead, we could actually ask the command, instead of querying and giving me the name, version, release, and architecture, just give me version. So if we go back up here and we change this command that we're doing to include, here's what I want the output of the query to look like. And this is documented in the RPM man page, by the way. Okay. So we're going to query. We tell it we want the output to be version and release, and we want that to be based off of the package name that was passed to it as the first positional command line argument. That's equal to the version that we passed in. All right, I think this is what we want. Whoops. If we write and quit it correctly. All right, so interesting. Oh, I need to put it in quotes. Still no. Oh, silly me. It's still going to fail because it's not the right version. So if I run it with the older version, 3, EL9_3, that passes okay. All right, so now the mechanics are working correctly. A couple weird things. Let's get rid of this this output here. Because I have that stray RPM queue in there. And I think this will do us. All right. So let's try one more time. So if I package test it, oops, with the new version, right, doesn't work. If I do a DNF update less, so that I install the updated version, and then run the package test again. Right now it is running the latest version, so it passes the package test. All right, and I see in the chat Shantanu is giving me a little chiding over whether I quote something or don't quote something, and that's like, it's a whole nother beast. All right. So now that we can do this on one machine, what does it look like to do this on all my machines? So let me create a file of machines that I know. Okay, so that's my list of machines that I want to work on. And we're going to execute this, this script by SSHing into each of these machines and checking it. All right, so, oops, not that one. So what we need to do is we need to take this this query format and check to see if it's there and print out the failure or success message. And we need to do that while connected to a remote host. So I'm going to add a little bit more stuff. All right, right? Because we're iterating, we're improving as we go. Okay. So what we're going to do, and actually I already tested this in another window. So I'm just going to copy and paste so I don't typo something and make myself derail the entire episode because I have a copy paste failure. All right, so what I'm going to do is I'm going to replace this if condition with another if condition. All right. So I'm also going to have to add a little bit more structure of, because you notice there's some extra variables that I'm referring to here that I haven't created yet. But essentially it says, hey, if I SSH to this system and I run this command and it equals my target version, then say it's okay. And if not, then it fails. All right, so the other thing we need to do is we need to add some flow control to our script. Right now, the script it runs one time through this if statement. And in fact, we want to iterate through all the machines that are in that file where I listed all the machines. So we're going to add another control structure that's really common for automating things, which is for. Then I'm just going to add a couple of white spaces in here to make things a little more legible. All right. So what for does is it takes a list here at the end, a list of things that it should operate on, and it is a white space separated list. So in our system's text file, there's each system listed on a line by itself. So that new line character is the white space character that's going to delineate which of the different systems we want to iterate over. And what happens is each time we enter the loop, we're going to take the next thing off of that list and we're going to assign it to this placeholder variable called system that I named system. And then we're going to iterate through the loop and then we're going to hit that done or go back up to the top and grab the next thing off our list, put it in the system variable, run through the loop. We hit done, go back up to the top, grab the next thing off of that list, put it in the system variable, and so forth until we have executed the loop once for every item that is in the list past the loop. All right, so that's where this system comes from. So it's going to SSH to this box. It's going to run this check, and yeah, let's see what happens here. All right, so now we passed the name of the thing, the version we're looking for, and the systems file where we have all of our stuff. All right, so yes. Yes. Okay. Whew. Well, that's not great because I have all this garbage on the screen. I just wanted the okays and the fails. So I'm going to do another thing. Notice I have this variable that I hadn't yet defined called SSH ops. So up a little bit higher in my variable definitions, way up here, I'm just going to make a variable. So what this will allow me to do is when I call SSH, it's going to look up what's in this variable and substitute all these options in. And what it allows me to do is down here where I'm making the SSH, I don't have to have this big, long, disgusting, ugly string of options because I define them up higher. And if I need to add another option to my SSH, like a specific SSH key to use or a user to log in as, I can make it here in the SSH ops variable And then any place where I use the SSH command later with opts, it's going to pick up those changes. All right, so let's try this. Okay, there we go. So no gross output for interaction, no interaction required for the SSH, it just works. Now, the reason it just works is because we actually did some SSH key exchanges on these two systems earlier. So they are able to authenticate to one another with SSH keys, and those SSH keys either don't have a passphrase or we have it cached using the SSH agent that caches passphrases for using keys. All right, one last thing I'm going to do. So, RHEL client. Did I make it wrong? Looks like it went to the same systems. I bet over here on RHEL client. Nope. Oh, why is it showing RHEL server? That's weird. Oh, I see why. So we said, look up the host name, which the first time threw it SSHs to itself, RHEL server. So the host name is correct. The next time, it's SSH and done checking over on RHEL client, but then when it's finished with the SSH session, it prints the host name. So I think what we really want to do here is instead use the system that we connected to check. There we go. See, and this is why we iterate. Line 11. Oh, host name system, not host name. Dollar system. Because system is not a command that we want to run. There we go. One more time. Okay. Whew. Man, took a long time. But here we are. So if I go over to the client system and I DNF update less, this would install the updated less, and then I get two OKs. But I would do one more change to my script before I do that. The other thing that I like doing, especially for these ones that report and will potentially go over this big pile of machines and then produce this report, is I want to be able to very quickly and easily, visibly see who I have to pay attention to. So the last thing I'm going to do is I'm going to change these two echoes for something different. Something really gross and disgusting. So it looks really gross and disgusting. But it'll actually be pretty sweet. So this string right here, this \033, blah, 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 this is actually telling the terminal, the bash shell's terminal, what color to use when printing to the bash shell. And so let me just go ahead and run it. So it's not just the color, actually, it's also things like the emphasis. So we can make things bold or other things. So, but the code that I put into it only changes the color. So if I had this giant list of machines, what I really want to look for is look for the red ones, the ones that have the fail messages. And then I know which ones I need to attend to. Right. So if I go back over to client, update less. All right. And then I run the package test one more time. All right. Now they're both good, right? Because they both have the targeted version on there. So again, this script is, hey, we have to survey our population of systems to make sure that there is a package installed or is a specific version of a package installed. And there are a bunch of different ways that you can continue to improve this script. One is you could actually make choices based off the arguments. So if the only argument you're given is the package name, less, maybe instead of reporting OK or failed, you instead want to report the version number of that package from the system. Whereas if you give it a specific version, maybe you want to have a failure, and then if it fails, also tell me the version that's installed there. So you can start to kind of customize based off of additional if statements to check conditionals, how we want to output and what data we want to collect. The other thing is, instead of putting our systems in a text file and then asking them to pass that out as a command line argument, right? If I know the text file is going to exist, I could just say, instead of positional parameter 3, just cat this file that I know exists. And maybe I put in an absolute path name so that we don't get bit when we run it from another directory. All right, so now I can just eliminate that extra argument, but my script works just the same because it uses this predetermined data. If you don't want to make your own file that keeps track of all your systems, maybe you're able to pull this out of a database, right? So you could use a database query, or maybe you're able to connect to a web app and get a list of servers that your organization has. So something like a curl or wget to make that connection to the web app and then process the data that returns to it. But so these are some two real life scripting challenges, let's say, that one could create. And notice they're real small. I will tell you that the color codes right here, I always have to look those up online because I don't remember the syntax for them, nor which color, which actual, like right here. So 32 medium width or medium heaviness, that's green, and 31 medium heaviness, that's red. And then over here, what we're doing is we're actually going back to the base font, right? No color font. All right, so we will take a quick look at the chat here. And I see that Vincent is chatting me about being over 30 minutes. Producer Eric and I talked about that beforehand. So yeah, that's cool. Yeah, Shantanu talks about options. So one of the other things that we can do for our scripts is we can actually put in options where there's like a flag, right? Like -p would be the package, or -v would be the version. That's a little bit more advanced scripting. But if you're making a utility that you're going to use for a long time, that might be worth the effort, right? To put those additional things in there. Cool. I will show you one other thing. So let me stop sharing this window and I'll share one more. So I said that it could be useful for doing an assessment of CVEs, right? A CVE affects a certain package, your risk management or your boss, or it's just good. You're a good security admin. You want to make sure that your fleet of systems is not susceptible to that vulnerability. And so you have the script that will go out and report on your fleet. And this is kind of what you would have to do if you're managing a bunch of different Linuxes, because like with Debian-based distros, you could do an apt or use the apt utility for doing this reporting to get the version and other things. Whereas on Red Hat-based distros, you would use RPM to get that information. But if you are a RHEL user, one of the things that comes in your RHEL subscription is this tool called Insights. And so if we take a look at it here, this is the dashboard for my account on Insights. And notice on the dashboard, it says, hey, there's 35 CVEs with security things that you should care about. So you can look at them. And as it populates the list of systems in my inventory, oh, here's a CVE specifically. And there's 81 systems that are affected by this one. So let's look at it. So here's the CVE, and here's how important it is, and here's the exact list of systems that I want to go care about in my inventory. All right, there's also some other stuff, like you can have it print reports for you, so you don't just have to use the web UI. You can actually get a PDF report to hand to somebody, and a variety of other things. So like, yes, traditionally, we write our own tools for these things, and if you're in a multi-Linux environment, you probably do some tooling of your own to account for these things. But RHEL boxes and Red Hat, like, it's pretty sweet. You just go, navigate the web app, bam, here's your report, guy. It takes, I don't know, 5 minutes less to generate the report that you can hand to whoever needs to have it versus having to connect to every box in your fleet and getting a report. All right. So you want to know more? Awesome. Thanks for making it this far. A couple of things that you might want to go further with. In our last episode, when we were doing a whole bunch of stuff on the command line, one of the things that we used a lot was the grep utility. And the grep utility allows you to take output from something or search through a file for something, and that something is a regular expression. And if you recall, Nate had this really gloriously difficult regular expression for finding IP addresses. How do you make those? What if you're not looking for an IP address? How do I make a regular expression? So there's a couple of articles that I will suggest to you. One is just basically how do you use grep? Using grep on the command line and searching for text in files. It's a blog that Red Hat has published called Finding Text in Files Using grep. But maybe you're beyond that. Maybe you actually want to get into writing regular expressions. So there's another blog entry that I think is a good start, a good primer on regular expressions, which is called Manipulating Text Grep. So this one talks about like using line anchors to find where this pattern exists, talks about using wildcards and a few other things that are kind of key to crafting regular expressions. And then the last thing I'll put on there is, so you wrote scripts and you have this pile of tools that you want to manage and you want to put them on your boxes, right? You want to install them in user local bin because those are places for local customizations for your organization. Well, how do you do that? I mean, I guess you could just SCP all these files around all your boxes, but that's super lame. So I would instead encourage you to look into building an RPM package that includes all the scripts. And we actually have a hands-on lab that will show you how to do it. And so this lab has a couple of different types of RPMs to build. One of them is a bash script. You want to just put bash scripts in an RPM. How do you do that? It's in this lab. I would say the lab takes about 50 minutes to complete, but we'll give you a good baseline on building RPMs. Today, we're going to be talking about command line tips and tricks. So Nate, what do you have in store for us?
What do I have in store? I mean, we have a lot of things in store. I mean, like so many things, all the best things, all the things that will save you time.
Yeah. Well, and so this is like things that we use mostly daily, although there's a couple that when we were doing research, I found, and it was like, oh, that's cool. I'll have to add that to my lexicon.
Yeah.
The big thing is,
and I'm a little sad that the one I really wanted to learn about doesn't always work. So we'll get to that later though.
The big thing is that not all of these are ones that you might want to do all the time. In my experience, you also have to work to like get in the habit of using them. Because if you don't get in the habit, then you don't use them and they just kind of fall away.
And some of them, it's like, yeah, there's a really cool shortcut that does that, but it's also really simple to just use the backspace key. So,
yeah. Well, why don't we jump into the terminal and we'll get started.
Sounds
all right.
Good.
So this is one of my boxes. And I want to start with one that I'm always shocked that people don't know, which is the tab key. So tab will complete bash commands or provide options if they're not unique. So for example, ls/v tab. So because there's only one directory at the top level that starts with V, it fills it out when I hit tab. And then if I do w tab, right, it fills it out as long as it's unique. And HTML tab, and then there's nothing in there for me to do beyond that. And then let's see. Oh, we could do it with commands. System tab. So I hit tab once, it didn't complete it. I hit tab a second time. Here are all the things that match what I have partially typed, right? Which is system. So if I make it a little bit more unique, system CT tab, it fills it out because there's only one thing that matches what I've partially typed. This is also really handy for commands that support bash completion. And so one that we've used on the show in the past is nmcli. So NMCLI, people complain because it makes very long commands to like do stuff. And so they don't
Very
want to
wordy.
remember all of the subcommands to do things, but that's cool because you can use tab to help remind you what comes next, right? So if I NMCLI tab, here's the next things I can add. So if I NMCLI connection tab, here are the things I can do with NMCLI connection, right? So I can use the bash completion, the using of the tab key to not only suggest what the next thing would be, but again, when I write it to be unique and hit tab, it fills it out. And if I tab again, like there's the things, right? So we can get things like our interface names, like ENNS4 or LO, so that you don't have to remember the exact contents of these like longer commands. You can build them as you go by at each stage. What comes next? Oh, it's that thing off the list. Cool. What comes next? Oh, it's that thing off the list. So tab. If you don't use tab, get in the habit of using tab.
And if I recall, this is extensible too. Like there's some sort of a plugin architecture where you can say what autocompletion, how it operates for a command, right?
Yeah, and so the RPM that gets installed is bash-completion.
Right.
And then any commands that honor bash completion will then start using tabs as their bash complete key of reference. So,
and if you double tab and there's a ridiculously large number of commands that are going to return, it even warns you, which I think is handy.
we've learned lessons over the years.
Yeah.
So that's one, right? The other thing that we wanted to cover in Critical Path today is history. History, basically, we keep track of all the commands that you've run in the shell. There's actually limits, but we'll talk about that in a second. So if you run the history command, these are all the ones that I've done recently. So you can look back at what you've done in the past. You can also re-execute them. So for example, maybe I want to DNF update kernel again. So I can use exclamation point, and that's command number 9. So exclamation point 9 will just re-execute that command out of my history. You can also re-execute the exact previous command. All right, so if I bang, that re-executes the last command that I've run. And Nate, you turned me on to something literally just before the show where you could use bang embedded with something else. So
yeah, I mean, how many times have you run a command and then you forgot to run it through sudo, right? This has to be the most common use for the bang command. I don't know how you didn't know this.
Maybe because I don't run with sudo because I'm bad. So you can see that it ran sudo DNF update kernel after I embedded the exclamation point shortcut.
Yeah, and you could also, like, if you ran, I don't know, ls, and then you're like, oh, but I'd really like to see the long list thing. If you did bang space -l, then it would show you the long list thing. So, imagine if you had a long command and you're like, I forgot that one flag. You just add that to the end. There you go.
Yeah, and you can see that right here, it actually prints out the command that it has interpreted that you wanted to run. So if for some reason it's giving you something crazy, you can actually see what it was that it ran that produced that output. Another one, and actually we were talking about search and replace a while ago, and a whole bunch of viewers were like, Control R, you savages! But we weren't covering search and replace on command line history. We were covering other stuff that day. Right. Control R, and you can basically partially type what you're looking for. So if I do a DNF, right? So DN is what I typed in. This is the last command that included a DN. Right. And so if I do a DNF install, right? And so on over here, it's showing, this is what I'm typing. And you can see it's highlighting out of the command history what it is, right? So if once you find the command you're looking for, you can just hit enter and it'll re-execute it. Or what I often do is press the right arrow key and it pulls that command onto my command prompt without running it so that I can edit it, right? So if I got close to what I wanted in the past, or I need to reuse something. So for example, one of my history, I set a user for this guy right here, set a password for user Joe. So maybe if I do a Control R, echo, right arrow, and I want to change what I set as password to. Right, I can bring that command onto my command line, make any customizations I want, and then hit enter to re-execute that updated command.
Yeah. Now, the thing I always wish Control-R did, and maybe it does, and I just never figured out how, is once it, say more than one command matches your search, I wish I could scroll through them and pick the one I want, right? Because maybe I don't exactly remember what the command was, or maybe the command I'm looking for is identical to the one that it found, but it's slightly different. You know what I mean? But like if you were to hit up and down there, it doesn't immediately search through those. I think that'd be a cool feature, but I'm not going to go like submit a bug or something over it.
I actually think there is a way to do that, but I don't know it.
I've never been bothered enough by it to go figure out if there's a way to do it.
So I said that at the beginning of talking about command history that it kept track of all your commands, and then I was like, well, not all. That's because there's actually a variable that dictates how many we keep. So if we do an echo $hist size, so we'll keep the last 1,000 commands that you've entered in through your history. So as you're doing a reverse search or using the up arrow to go back through your history, you'll get up to the last 1,000 commands. If that's not enough, you can change the hist size variable. In fact, there's a couple other history related variables too. If we do a set, type into grep hist. So set is all the variables that are set in my environment. That's also ones that are going to be exported to child shells. And so we can see that there's a file where all the history is synchronized. So when I log out, it actually takes history from my session and puts it in this file so I can have it the next time I log into the machine. That hist file size will be 2,000 commands. So there is a finite size to how much we'll store, but if you want to change it, you can change the hist file size variable. And then what we're keeping live in the memory of the shell is 1,000 commands. So you can adjust these variables as you see fit if you want more or less history stored. The I guess downside is that the more history you store, the more memory gets used by your shell for storing the history data. But I mean, these days, do we really care? I mean, we've gone past the no one should need 48K of RAM days of your
640, by the way. That's the quote. 640.
Oh, 640? Okay.
No one should need more than 640 because he was talking about MS-DOS.
Right. All right. So that's a little bit on command line shortcuts and like tips and tricks. We covered tab and history. But stay tuned because we're going to do even more. We're going to talk about a whole bunch of key character combinations. And if you don't use it, you won't remember it. So you pick up the ones that are really useful for you. You practice them to get them embedded in your habits, and then you'll use them forever. I actually have one later on. You may have noticed as I was working, I was clearing my screen so you could see everything at the top of the screen. And literally today, somebody was like, why are you using the clear command? Here's a key combination to do it. We'll talk about that one. But I was like, well, because clear's my habit. Something I've been doing for like decades. Yep. So yeah, yep. I learned something new from a viewer today.
We always learn something new when we do Into the Terminal. That's part of the fun, right? Like
that's
you
right.
You get those habits, you get the things that you type out of complete muscle memory, and then you're like, wait, I've been typing 5 more characters than I need to all these years. All those keystrokes.
All those keystrokes I could have saved.
Yeah, all that carpal tunnel I might have avoided.
So Nate, are you going to show us some around like moving around stuff?
Yeah, so these are sometimes useful, sometimes not. These are things I'm actually not in the habit of using mostly, except a couple of them, right? So Scott had showed you history, right? Up and down arrows here, right? So that's one thing you can do with the arrow keys. The other thing is, I don't know, let's say we've got a long command, like, I don't know, cat etsy shadow, right? And we did the thing, and then we're like, oh, but what I really wanted to do was like change etsy shadow. Use the left and right arrow keys to move around, and then you can just change this by backspacing it and then say like Vim, I'm going to open it Etsy Shadow in an editor instead, which, by the way, you probably shouldn't do unless you know what you're doing, but this is an example, and this is a lab system, and I can destroy it all I want. Okay, so that's one thing. You can also move to the start of a line, and this is where these control keys start to come into play. And these are like a throwback to the days when keyboards didn't necessarily have all of the cool functionality that we have today, right? Maybe you didn't have arrow keys to work with, so you use these control sequences to move around in like mainframe days and stuff, right? And a lot of these are just from that, right?
Not mainframe days. They were Unixy things and terminal.
Whatever, the old days, those old fogey days, right? The really long bearded graybeard days. Anyway, but you have to admit, a lot of this is historical, right? This is people, as they were moving into Unix, were coming from things like mainframe. A lot of these control sequences a lot of them are historical, but so many people are so used to them. So Control E and Control A. I'm going to do Control A first because I'm already at the end of a line. So maybe you can guess what Control E is going to do. But if I do Control A, it moves you to the beginning of the line. Control E moves me to the end of the line. And that can be helpful if instead of going like this, right, to get to the beginning, or like this to get to the end, you just Control E or Control A. Now, I believe the end and home buttons will also do this on your keyboard. However, some terminals don't respect the end and the home buttons. And I was just doing this yesterday. In fact, I was working on something on the command line on my MacBook here, and the home and end buttons just weren't working. I think they normally work, but for some reason they weren't. So Control E and Control A can save you there.
So Nate, I use Control A and Control E all the time.
Yeah.
Because like you vimmed Etsy Shadow. Oh wait, that's not what it said. It was in read only.
Right.
So maybe you want to change that for ls-l Etsy Shadow, but you don't want to use the right hand or the left hand arrow key to move all the way back, especially if you have a real gnarly command line with all kinds of pipes. So it's like Control A to move you to one side, Control E to move the other, because those are often where you want to make changes, how you started the command line, or adding options or additional arguments at the end of the command line.
Right. Right. And there's also a control sequence that'll move you one character at a time, but there's really no reason because your arrow keys will do that. If you don't have arrow keys, I don't know what you're doing today.
Yeah. I mean, so that one is a throwback to like
the
1980s when terminals didn't have arrow keys on their keyboards.
Right.
So I had to be able to like move between stuff.
Yep. And another one that I unfortunately can't show you because this is another case where it doesn't work in every terminal, but it does work if you're in an actual Linux terminal or if you're at a console or something. And that is you can skip ahead and back a whole word at a time, right? And those are Alt B and Alt F. Alt B will move you back a word and Alt F will move you forward a word. But you can see how if I do this here, Alt B just gives me this weird command or this weird character, right? And Alt F will do the same thing. It gives me these strange characters. And that's because of a terminal emulation problem. It's either Mac OS interprets them weirdly or the web console we use for these terminals interprets it weirdly. Either way, I couldn't make it work for my demo, but I did try it on my Fedora laptop and it worked great there. So your mileage may vary.
So I think you're right. Like, we're running this within Chrome. Well, does Chrome intercept the alt something? It does. And so that's why you're not getting the behavior that you're expecting. Or different operating systems may have slightly different things. Like if you're using PuTTY on your Windows machine, Windows may capture some of those control sequences as native Windows controls because it thinks that you're talking to it, not that you're trying to pass that stuff through to the session that you're using PuTTY to connect with.
Yeah, and the alt key is usually used by your window manager, whether you're on Mac, Windows, or Linux, to do things like menu shortcuts. Control is also used for some of those, but it's not, in my experience, it's not as frequent. Alt is like the go-to for those commands. So that it could be anything. It's grabbing that alt key when I hit those buttons.
Yeah, and oftentimes there's like yet another key that you can use to protect that key from the operating system intercepting the key. So it's like, Shift Alt something or open Apple key Shift whatever. So there's like keyboard combinations upon keyboard combinations, but why do you really want to do that to yourself, Nate?
Yeah, at some point it's how much do I have to remember to make the keyboard combination work versus how much do I just use the arrow key to get back to the thing that I care about.
There we go.
All right, so Scott, you've got some on inline editing here of commands, right?
Yeah, so I talked a little bit about that with history earlier, where you can like recall the command to your command line and then you want to make changes. Well, how can you make changes a little bit faster than using arrow keys and backspaces, right? So just a couple of things. So if I ls var html, there's nothing there, but I wanted to edit a file. So I can do vi, and then instead of typing that whole thing again, even with tabs, I can just use escape period, and it will pull the last token from my previous command line into my current command line. So I use this one all the time because often I'm like looking for something or I found something, but I want to run another command on it. And so I'll replace my command and then pull in that last token from the previous line. And notice that it didn't just execute it, it just pulled it into my command line where my cursor was. And then I can do something like continue to edit and make changes.
Super businessy.
Yeah. All right. Maybe I want to do another thing. Like I want to long list I want to list this file now, right? I tried to list it earlier and it wasn't there, but now I want to list it now that it is there. So I can do a caret vi caret ls. And what this will do is it'll go to the previous command. It'll look for this search string vi and pull it out, and it'll replace it with the second string ls, and then it will automatically execute the command. So I don't get an option to like make changes to it. It just does this search and replace and executes it. It will only do the search and replace on the first instance of this character set, right? So if I had multiple places where the word vi was used on that command, it'll only replace and re-execute the first one.
So maybe you want to check your history before you do this, is what you're saying.
I mean, usually because you're working with the one previous command,
Yeah.
visible, but it's not a global search and replace. It's a singular first occurrence search and replace.
The first occurrence in your history, though, right? So if you don't get the match right, it could match something further up in the history and then just run it, right?
Also, yes. Also, yes. All right. One of the other things that I do a lot is I will edit a really long command. So I sometimes do really long single line shell scripts, and will want to like do something at the beginning or the end, or maybe cut off something. So if I recall my previous command, I'm at the end and I can move to the front and use my arrow keys. Now I'm close, and just like make a change and hit enter to re-execute it.
Right.
You can also do move to the front, move somewhere like here, and control E. Oops, sorry, not control E, control K. Control K will cut from the cursor position to the end of the line. And actually puts it into a copy paste buffer, which I learned today too. I always just use it to edit stuff. I didn't really care about pulling it back. But if you control Y, it puts it back. So it puts it in a copy paste buffer, and then you can paste it. And if I want to, I can just keep pasting it. I don't know why I'd want this many, but I can.
You never know. There was another one, and I think we in our preparation for the show, I think it got dropped from the notes. But there's another one where if you're at the end of the line and you want the last thing, right? Like in your example, the var dub HTML index HTML. If you wanted that whole chunk, you could say there was a command that would grab that, right? So I wanted to grab that one thing and then maybe do vim and then the thing, right? And then you could cut it out,
so,
do the thing, and then paste. Yeah.
Yes, that was control W.
Yeah, that takes what's before the cursor. It'll take the last thing that's before the cursor. So yeah, you had the right command, just you had the cursor in the wrong place.
Yeah, and then, well, here, let's do this. You can also do an undo of an edit. I don't remember what it is. All right, so control W pulls the last line from before the cursor, and it pulls it into your copy paste buffer, right? So,
yeah, so now if you were to like control C and then say vim and then paste that in, then boom, there you go. There you go.
Yep. You can also do cut from the cursor to the beginning of the line. So if I do that and then come up here and do control U. That cuts from the cursor all the way to the beginning, so I can lop off all that stuff, and it puts it again in the copy paste buffer. So I could do this and then Control Y. I can still copy and paste out of that buffer that I put that thing that I cut into.
Yep.
All right, so that's a little bit on editing. I actually found this really cool graphic on GitHub to demonstrate this. So let me see if I share my other tab. So this was on the GitHub, and I'll put it in the notes as well, for a user named Flip the Web. Flip the Web had a whole bunch of bash command line shortcuts, but what I found really nice is this graphic that he made that shows
handy.
like these are the controller characters for moving around, and it showed you like how the different characters would move you. And then also these are the characters for making edits and getting rid of stuff. So you can do like to the word boundary or the entire line. So there's some other alternatives.
That's handy. So, print that out, stick it to your monitor, and you can get used to using these things.
Maybe, if that's what you want to do.
All right. So I've got some more on some swapping of things that are already typed on your terminal, right? So there's two commands I'm going to show you here. So raise your hand if you've ever done this. System CLT. And then you're like, whatever, status foo. And then you're like, oh, no, that's supposed to be system CTL. Well, there's a keyboard shortcut that'll take the two characters before the cursor and transpose them. Apparently this happens enough that that there's a keyboard shortcut for this. Now I could just go bang, bang, and then L, TTL instead. But if I do, let's put it back to where I had it. It's Control T will transpose them. Control T, bang. Oh, what did I get wrong there?
Oh, your cursor was in the wrong spot.
My cursor was in the wrong spot. No, I've totally messed it. CTL, CLT, right? Okay. Now,
There you go.
Now, there. Control T. There we go. No, it did it again.
Because you
I don't
need to
know.
be on.
This worked before. I'm telling you. No, look.
I think your cursor needs to be on the end of the
No,
character.
there. Look, it worked. So it must have been the space that was after it that was messing me up. So maybe you're right. It was supposed to be here. I don't know. Anyway, the point is you can transpose two letters. Now, again, this is that's neat. It's kind of cool that it does that. But what if instead I did system CTL? And you might remember in the days before systemd, we had that command service, and then you would give it the service name and then the command you wanted to run. So for a long time, when I was using systemd command, systemctl, I would do this and then go, well, no, that doesn't work because it's supposed to be the other way around. It's supposed to be the command and then the service, because you can put a list of services if you really wanted to, right? There's a command line shortcut that will also swap the last two words, and that's escape T, right? Wasn't it? Yes, escape. So you hit the escape and then the T. And there you go. Swaps the two words, which I think would have been really handy to know, I don't know, 10 years ago when I was transitioning from the old service to systemctl.
Yeah, that would have been super handy.
Would have been good to know. Good to know. But, here we are learning these things, learning them together.
Well, and sometimes things like firewall rules, sometimes ordering matters between them. So that's another place where transposing the words may be helpful as you get some errors. It's like, oh, this is not the right argument for that. It's like, oh, let me go and transpose these two things and
right. Right. All right. Next, we're back to, you've got one about weird things.
Yeah, weird things.
Tell us about weird things, Scott.
So, weird terminal things. So let's say we accidentally cat a binary. right? And you can see that my command is all messed up because in that binary, there were all kinds of control characters and stuff that got interpreted from trying to turn that binary into text. And my command's all messed up, right? You see it there. It's like bracket,
all kinds of broken.
Cyrillic character. Yeah. So one might try to log out and log back in or close their window or whatever. You don't need to do that. You can actually just use the command reset.
Which you can't see, but oh no, it didn't work.
Oh, that's because of my terminal emulator. So let me just refresh the terminal emulator quick. There you go.
There you go. Reset would have done it at a console. I've done that a bunch of times.
Yeah. Reset will also reset the size. So if you've ever been on like a machine that's using a window emulator for your terminal and you resize the window and you're running a command like top, but it doesn't use the whole window, It's still like the smaller size. Reset will also resize the window based off of the current size of what's there. Or the opposite, if you've made the window smaller, but your output is not smaller, it's doing all kinds of wrapping because it thinks the terminal is bigger. Reset will refresh the column and row data of your terminal size and make sure that your formatted output understands the size of your terminal.
Apparently, Shotnu's been rebooting all this time to fix that problem.
I doubt that's the case.
I think that's true.
You could see that you couldn't see it when I was typing it, right? It was all coming out crazy.
Yeah.
But if we look in the history, right, it's there. Like that was what was actually going into the terminal was the reset command.
Yeah.
The terminal settings were all wonky.
The character set was all messed up. Probably what happened.
But man, that's way easier than like closing and reestablishing your session or whatever else, right? So that's a simple one. The other one, and this is the one that I alluded to earlier from a viewer, right? So I always use the clear command when I want to clear it off and bring it back to the top, but Control L will clear the screen. Who knew?
Yep.
I'm saving 4 characters of typing there, Nate.
Yeah. And honestly, Control L isn't that hard to hit because it uses 2 hands. Control with one, L with the other. There's no like weird stretching with your hand to try to get the things. I've been using that for years, and I picked that up, well, from some of the like super crazy sysadmins that were in the team that I joined about 15 years ago. It was just like watching these folks at the bash prompt was just, I learned so much from those folks. Things that I never knew existed, like a lot of those control commands, Control L, Control R, and it actually came up in chat, and we weren't sure we were going to get to this one anyway, but Control D will log you out of a session, right? Which I think is super handy instead of typing exit or log out, which is a much longer command, right? All right, so let's see. We got 2 more, I think, from me, and then we're going to wrap it up. So let me get my terminal back up here. Okay, so command aliases is really helpful. Now, did you know when you do an ls, you know how when you do it, let's do an ls of like Etsy, right? All this color output, that's not default ls behavior. That's an alias that comes out of the box with RHEL and a lot of other Linux distributions because it's super helpful, right? This is when you run ls, it's assumed that you're going to run with the color output. And another cool one that a lot of people use is a shortcut called LL, which gives you a long listing, right? Instead of doing ls space -l, you do LL, and it does that. Well, these things aren't separate commands, right? They're aliases. And if we run the command alias, alias, it's hard to type, really. You can see that these are the built-in aliases that came out of the box with this particular system, right? And there's also ls-a. I don't use that one that often. But there it is. It's there in the aliases. So L is ls-cf, which I'd have to look up what that does. LA, LL, LS, these are all, really common commands that someone decided should be aliases. But you can also see there's a grep alias here that adds color to the output of grep, which is really handy. Same deal with fgrep and egrep, right? So those are good things to know, right? That you can also make aliases, right? If I just did like, I don't know, alias foo. Oh, I didn't mistype alias again. Here's that tab thing. Foo equals, I don't know, ls-l. And then I just type foo. There we go. A lot of people I've seen take and make an alias for that bang bang command earlier that we did earlier, where they do like alias, I don't know, I keep mistyping alias. Oops, we'll call it oops. It equals sudo space bang bang. And now if I type the word oops, right? So now if I did like, I don't know, cat, Etsy shadow, and I was doing that as a standard user and I forgot to do sudo, if I just type oops, it'll do it with sudo. Oh, somehow I messed that up when I made the command. But anyway, the point is that you can make it. I'm curious why that didn't work. I've seen this work in the past. You can make aliases that'll do things automatically. What?
I can tell you why. If you look at the alias, just run alias command, you'll see that it's because the bang bang.
Yes, because that was the last command I did.
Yes, but it gets put in there before the alias command is run. It's
there's
parsing.
There's a way to make this happen. I just haven't looked into it. I did it on the fly here. I've seen this done. I've done it myself. There must be an escape sequence you have to do that makes it not transpose that for you.
You want to use an escape sequence in your alias command so that the actual token that goes in there is bang bang,
right?
Rather than the bang bang being substituted for the previous command when it builds the alias. But quoting with exclamation points is weird. So you could try \bang.
Curious if I just do single quotes, if that'll be enough.
It won't work.
Ah! Now I hit the up arrow on accident. Whatever. We're not going to waste a whole bunch of time on this. My point is, if you can get the right sequence to escape it properly, it will work. And I see in the chat, people are already making fun of me. Trust me, bro, it works. Trust me, it works. I've seen it done. Totally. I'm not lying to you. All right. So the next thing I wanted to show you. Sorry, you have something to say?
Oh, I was just going to say, another comment in chat talked about making these things persistent. And I know you're going to get to that in just a minute too, Nate.
Yeah. So really the next demo is about making a dynamic prompt for, well, we'll just say reasons, right? And the example I'm going to use here is, let's say, because I've done this in the past, when at my last job, we were moving from a world where we did not have SELinux turned on to a world where we did, because we were trying to be better about being more secure. We had a lot of times where when you log into a machine and you're troubleshooting a problem, if you don't think to check SELinux, you might not realize that it was set to enforcing instead of permissive, because you're in a world where some systems are enforcing and some aren't. So we made a prompt that had a little token in it that said SELinux is whether it's permissive, enforcing, or disabled, right? And it would even, I went crazy with it. It made it colored and it put a little token in there, like all kinds of stuff. I'm not going that far with this example, but there's a command, or I should not say a command. There's a environment variable called prompt command. And what this will do is every time the prompt is executed, it'll execute this other command. So what you can do is you can have something that'll dynamically like populate a variable, and then you can use that variable in your prompt when you actually display the prompt. And then as long as prompt command works properly, it'll execute the thing, it'll set the variable, and then your prompt will change based on what's in there. So what I'm going to do is put this inside of Bashrc, because that's where on this system where the prompt is set. So we're going to search forward for PS1, and right there it is. There's the prompt that's getting set for this machine. Now there's also bash profile where you would normally set things like variables, but for whatever reason on this system, it's set in Bashrc, and Scott and I talked about this before the show, and we didn't really delve into why. But just know that bash profile is also an option here. But you're going to want to put this particular thing in Bashrc, because you want this to run whenever you execute a new session, a new terminal, even subterminals and whatnot, if you want this prompt to show up. All right, so let me get to the actual thing here. I'm just going to copy and paste this because I have a bunch of variables in here that are hard to retype, and I will typo them if I don't copy and paste. So here's what we're going to do. We're going to set prompt command, and I got an extra space on accident. So the variable name we're setting is prompt command, and what it's going to do is it's going to take the variable name PR SE status, because I thought SE status might already be a variable that I didn't want to overwrite. And it's going to set that to the output of get enforce. Now, you can get a lot fancier with this. You can put logic and whatever in here, but I'm not doing all that for this. And then what we're going to do is in the actual prompt, we're going to add after sort of the end of the prompt where this prompt is a little complicated because it sets colors and it sets, other things that are dynamic. So I'm just going to go right to the end of it. And I'm going to put a parenthesis because that's what I want to actually display in the prompt. We're going to do parenthesis, and then we're going to go the name of this variable that we just set. Oh, I don't want all that. I just want this. There we go. Let's see, $, and then the variable name. And we're going to close my parentheses. Now, again, these parentheses aren't part of the command. This is just what I'm going to display, and you'll see in a minute. Okay, so now I've basically said, set the variable, and then we're going to print out that variable when we execute the prompt. Okay, now we're going to save this out, and now's the moment of truth. This doesn't work immediately because Bashrc only executes when you start a new session, right? So to start a new session, we're just going to use su-, which basically says, make me a new session and bring in the environment for the new session. And now you can see that my prompt has this extra thing in it that has the parenthesis enforcing parenthesis. That tells me that on this system, SELinux is in fact enforcing. Now, if I do a set enforce 0, and Dan Walsh cries when I press enter, now it immediately tells me, oh, this system's permissive now, right? And if I switch it back to enforcing, there it is, enforcing. So there's one caveat I want to bring up, and maybe this has already been going through chat. I don't know, because every time you mention something like this in a prompt, somebody has this comment. Don't put anything in here that's going to be resource intensive. Don't put anything in here that's going to take a long time to run, because every time you execute anything and it brings the command prompt back, it's going to rerun this command. Also, you could end up in a situation if you're trying to connect to a system that's already resource constrained for some reason, like it's out of memory or the CPU is bound up. It could make your prompt not display because it's trying to run the command and can't. Right now, that may eventually time out and still get you to a prompt. I haven't really exhaustively tested that. It might be smart to put some sort of logic in there that figures out if it can run the command before it runs the command, right? But then, again, this gets into like a chicken and egg problem. If there's no resources, it may not be able to run the thing. So just keep that in mind before you start putting all sorts of awesomely crazy cool things into your prompt. I've seen people use this for like Git statuses and things like that. Again, unless you want to run Git every time you bring up a prompt, maybe be careful, right? All right, and I think that brings us to the end of the demos.
So there was a little bit of chat going on. Two things. One, there was some, like, you can use colorization, which I think you mentioned you used, but yeah. Penguin said they use colorization for things like if you're logged in as root to indicate that maybe you're doing something you shouldn't. Also, there was some discussion about profile versus RC. So I'll put this in the stream for our deferred viewers. Profile is run by the login shell when someone establishes a session. So a lot of times you'll see the stuff that gets set in a profile, like when you SSH to a box for the first time and you're logging into it, you get a login shell and hence the profile is executed. I don't know, log in at the terminal. That'll work. Or you're logging in through ILO, that'll work. Because those are all login shells where you're authenticating the machine and you're creating a shell for your session that you then get dropped into. Where the differential is really important is when you're using additional shells. So for example, think about when you log into a graphical desktop environment. The graphical desktop environment is what runs within the shell that you logged into. But when you're creating new GNOME terminals or what have you, those are not login shells. Those are additional shells in your existing login session. And so for those, the bash profile is not executed again. It's only executed once for your login shell. And so the RCs are for running commands, and that's what gets executed every time you open up an additional shell. You don't get the profile re-executed, instead you get the RC re-executed. And the reason for that is profiles is where you set variables and you can export them, which means subshells will also get them. But you can't export a command. You have to re-execute a command or run the command, hence RC.
Right. And I just catted out the bash profile in this user's home directory just to show people what's in there. Not much. In fact, it sources Bashrc. So, yeah.
And Bashrc is automatically get executed when you open up a subshell. So if you actually ran the command bash and you created a subshell, and we get the RC, but would not get a profile re-executed for it.
Right, right.
Real quick, if you want to create a shell script, it's really just a set of instructions that you want to execute. And at its most basic level, it's a series of commands that you want to execute in series. So you can just create a whatever you want to call it. The actual name of the script doesn't matter. We don't deal with file extensions or really care about file extensions on Linux. But commonly, a good rule of thumb is if you're writing a script, you actually extend it with SH. So other people, when they're just looking in LS, they know that this is a shell script. Then at the beginning of the script, you indicate what shell interpreter should be used. So there are a couple different shell interpreters that come with Linux. With RHEL, we typically use Bash, the born-again shell, but you can also use C shell or enhanced C shell, also known as TCSH, or Corn shell. So there's other options there. And you often see this also specified for interpreted languages like Perl or Python. They'll have this, we call the shebang, right? The sharp exclamation point or pound exclamation point statement at the beginning that says, this is the thing that should be used. This is the executable that should be used when processing the instructions that are further on in this file. All right, so let me just save this real quick. The other thing we want to do is if we want to run this script like the command, you want to make it executable. So I'll just use chmod here and make it executable. Right, so you can see there's the X permission on user group and other, and then thanks to our colorized LS that we use by default, it shows up as this bright green that tells me it's an executable.
So fancy.
Yes, fancy, fancy. All right, so actually writing the script. So I said that one of the things that scripts do is that they are a series of commands, right? So maybe I was writing a script that is a, I don't know, quick health checker of my machine. Let's do SE status. Okay, so when I run the script, it's just going to run these three commands in series. Right, so we get our df, right here. We get our free memory available right there. And then down here, we get our SE status. And it's not super readable at this point. So we could do stuff like add in a couple of echoes, right? Echo is how we print things from a shell script, but with just an echo by itself and no text to print, it'll just make a new line. And we could also maybe add in some headers. Oops, I need to echo that.
Yeah, that's not going to work that way.
Oh, you know. That's what happens when we do things on the fly, Nate.
What do you mean? Hours of prep went into this episode.
Actually, let me say... All right, so we'll save, run, quit, and then we'll run my script again. Right, so now we actually get our header, and before that, in between each command, there's a couple of new lines. Right, cool, awesome. I'm making it look a little bit better with some echoes. All right, but one of the things you might want to do is instead of just like barfing out a df-h or a free or an SE status, maybe you're only interested in certain parts of that, right? So for example, maybe for df, instead of just all file systems, maybe we should do a little bit of constraining and say, hey, we're going to take that df, and instead of showing you all the df stuff, we are going to instead grep for either let's do -e, a 8 and a character or a 9 and a character or 100. What do you think I'm looking for there?
I would guess the percentage used.
Yeah. So
80, 90, or 100.
Exactly, right? So now, and if I'm smart, oh, look here. There was a 9 in any character and an 8 in any character.
Oh,
So I need
no.
to tweak my grep a little bit.
Yeah.
Also, right, like here's 8 in any character or 8 in any character. So maybe it should be 8 in an character percent or 9 in any character percent or 100 in any percent. So we're actually binding it to
now there's nothing.
Yeah, which is good. Like I don't have to worry about that. Right. And in a bit, Nate's going to talk to us about things like conditionals. So instead of having a blank, maybe what I would instead say, if the output of this grep is blank, instead say no file systems in danger of usage or something like that as a message.
And you could pair that with like awk and sed and probably improve on that logic so that it has less chance of catching, extraneous things, right? I think you're pretty good with the 80, 90, or 100 along with the percent, but you could do better, right? Because you could use awk to say like, pull out this particular column and then do logic against it. Is it above a number, right? So.
Yeah. So, but to get started with just like paring down.
Right. Yeah, that's a little beyond what you wanted to show. I'm just kind of mentioning it.
Yeah, fair. Like shell scripting is an immensely broad topic, and you can get into a lot of interesting things. And there's a lot of additional programs like sed and awk that Nate mentioned, or like stream editing with Perl or sed. So there's a lot of things you can do with it.
Thank you for bringing up Perl.
Like, if I always bring up Perl.
Or Perl. Nobody likes Perl anymore.
Maybe we want status and policy, right? Oh, and mode. So I could go in here and say, take SELinux status and pipe that to, what did I say? Grep-e policy -e mode and -e status.
Status or something, yeah.
I thought so. But that was all caps.
Now you could do a -i that says case insensitive, right? Then it wouldn't matter.
All right, so I need policy and name, and then I didn't get the status right. Let's see what it was here. Oh, lowercase status. Okay.
But you're going to catch the other status too.
Could be. And that's okay. And policy name.
Rick's on my side. He loves Perl. In the chat.
I mean, who doesn't love Perl? All right, so this stuff.
He also had another grep for you for when you were dealing with the numbers that would use a better regular expression.
So I saw that 0 through 9 is not what I want to use though, because if it's 0 through 9, then 10% would also have matched my critical file.
Could have done like 8 to 9.
Yeah, possibly. Yeah. And then I could have less egreps or less extended options for grep, but
fewer processes that you're running, right?
I mean, really? Yeah. In theory, yes, you could do it all from one grep pass through the data. But in today's world, like
it just doesn't matter that much. It just doesn't matter.
I can be inefficient if it saves me time, because my time is actually the most valuable resource.
Right.
All right. Cool. So that's a little bit on like taking a command and then crunching it down. The other thing we can do is we can actually pass arguments to our shell script. So let me say, maybe I invoke my shell script like this, and I want to pass arg1 and arg2. And so inside of the shell script, you can actually see what someone passed on the command line to it. And that gets stored in a what we call a positional parameter in the inside of the shell script. Echo. Parameter.
Yes, the spelling matters here, Scott.
Yeah, there we go. It does matter. Spelling does matter. And then we can say something like echo dollar. Echo argument $1 arg. Sorry, $1.
Yeah, $1. Now you're thinking about Perl.
I am. See,
it's like argv or something in Perl.
Yes, it is argv.
As an array.
$2.
Right. And there's also, just to be clear, right? Why did it start at 1? Because 0 is actually the name of the script. So if you wanted to bring the name of the script into the script for some reason, you could do $0.
Actually, a usage error message is often why you would use that.
Yep.
Because then you can like write a little segment of usage error that you can reuse in all your shell scripting because it references the name when printing the error.
Yep.
All right, so you can see down here at the bottom, right, there's my 2 positional arguments. And when I change the name of the argument, right, it changes what's stored in that variable within the script.
Right.
So this is how we can do things like maybe I want to choose what comes out of the report. And so I'd pass arguments like fs, mem, SELinux. And then inside of the script, I would actually make decisions with maybe an if control structure to say, if I'm passing an argument of fs, I need to do the file system report. If I'm passing an argument mem, I need to do the memory report to allow for more changes in the execution of the script. Or if we're doing something like our organization has a bunch of user things that has to happen for when new users get added to the system, we could write a little script that would do all of those things, but almost all of them are going to rely on the username that we're adding to the system being provided. And so we could provide that username as an argument, and then it would go through into each of the modules of adding the user or customizing them in some way, and would have that username that we could use throughout the body of the script by referencing this variable. Yeah, and I see Chateauneuf was about to say the other thing that I was going to show.
Argumentes.
All right, so it's a little bit easier to read. So $* is everything that was passed. Right, so here we go. There's $*. So you can refer to them individually by the position. Are they the first argument? Are they the second
or all
argument?
of them, right?
Third argument? Yeah, or all of them. All of them is used when you're doing things like grepping. So if you want to see if something was passed, but you don't care when in the positions it was passed.
Oh, right. There you go.
Grep against $* to see if it's just in there. And that might be easier for something like if we were passing arguments for what reports to run, we might not care that FS was first on the list, right?
Yeah.
It just matters that it was in there. So yeah, that's a little bit on positional parameters. And as Rick and Nate mentioned, $0 is the shell script name, right? So I can say $0. Right, so this is whatever was passed on the command line to invoke the script.
Right.
All right, so that's a little bit on shell scripting, and specifically it's on running shell commands within your shell script, and then also positional parameters of your shell script. But first, we're going to hear from today's sponsor.
A word from our sponsor.
Yeah. So today's sponsor is Dev Null VPNs, the most secure VPN on the market.
Nobody gets your data.
$1 million. You too can run a Dev Null VPN. But you may ask yourself, what is this fantastical technology that powers the Dev Null VPN? And the answer is Dev Null. What is Dev Null? So why don't we show you on the terminal real quick?
Right after I closed your terminal. You were not clear. Here.
All right. So Dev Null is a special magical character device defined on all Linuxes. And you can see that it's writable by everyone on the system. The root user, people in the root group, and all others can send data here. And this is actually implemented in the kernel's memory management source code. And essentially, it is a in-memory device that takes as much input as you want to send it and provides no output. It will end up like doing a return value of like the count of characters it received or something weird. But essentially how we use it normally is we just direct stuff to it, right? So if we do a find name foo and it's running, well, that didn't help, did it?
You don't have anything named foo, apparently.
Well, I knew that. I was hoping for some error messages. All right, so like, here's a bunch of error messages that you're not allowed to access because you're a regular person. But we can direct error messages to Dev Null, right? This special in-memory device, and it takes all those error messages that normally would be sent to the terminal and redirects them to this special device that accepts all input and provides nothing back. So it just throws away all of that data. So how does this relate to Dev Null VPN solutions? We asked ourselves, what do we care about for secure VPN solutions? And the answer is clearly security. And then we asked ourselves, what can we convince users to live without? Could we ask them to live without user interface? Yes, we don't care about that at all. Could we ask them to care about functionality? Yes, we don't care about functionality at all, because the only thing we care about at Dev Null VPN solutions is security. So how we implemented this is we took all your network traffic and we hook it into Dev Null special magical kernel device so that all the network traffic, instead of going out to the internet where it's dangerous, you don't want to go out there. Instead, it just goes to Dev Null such that the traffic never leaves your computer, thereby making it the most secure VPN solution ever invented.
And also, you know, gone. Nobody can take data that's gone.
Sure. Because if there's no data to capture, then there's no risk of having your data captured.
All the security with none of the usability.
That's where we're at Dev Null VPN solutions. All right. So we're going to transition into the deeper dive. Nate, you're going to be talking to us about conditional statements and looping.
My favorite thing, the for loop.
And there's something else on that list too.
Well, there's a couple different types of loops that we're going to go over and conditionals. So there we go.
All right. So Nate, tell us about conditionals.
Yeah. So hold on, let me get there we go. All right. So with any script or any program, the thing that makes it useful usually is conditionals. I mean, you'll have trouble finding any script or any program that doesn't have some reason to do an if or an else, right? Logical comparison to determine if a thing is true or false, right? So I made up a script here. We're gonna I'm clicking the wrong window. I have two things, right? It's not okay. I made this relatively long example script because there's a couple different examples I wanted to go through. So I set some variables up here at the top. The ones we care about right now are A and B, right? And they're just numbers, 10 and 20. And I have a block here that is an if, then, else, right? Now, this is like one of the most basic things you learn in programming, right? If, then, else, right? So what we're checking here, and the way Bash does if statements is you have the word if, which is actually a built-in internal command, right? You can run this right at the command line the same way that you would within a script, right? Just like Scott was showing us in the critical path. And then we have these braces that open up to say, what am I testing, right? And in this case, I'm testing the variable $A, which we see is set to 10, -LT means is it less than, and $B. $B is, of course, 20, right? That's another variable we set at the top. And then we're just going to echo out the output there. And I see an error here from the copy paste. Let me fix this one down here before we do anything else, because that's going to break my script later. We don't want that to happen. Okay, and then you can see that we have this second command here that says Elif, right? Now, the way if is structured in Bash is you say if and then. So if this first line returns true, then it will do the thing that's between the then and the next command, which is Elif, right? Now, Elif is like a continuation of if. This is, if that first one returned false, then we want to check this second thing too. And the second thing is A greater than B? So you can tell here, we're trying to catch both cases here. Is A bigger or is A smaller? And then we say, okay, A is greater. And then we're going to go into an else, which is, it's not greater or less than, right? So let me show you how that works. Oop. I hit F1 instead of, there we go. Okay, so we're going to run if example. And you can see 10 is clearly less than 20, and that is true, right? Bash is not too bad at comparing numbers here, right? So now we're going to edit it again, and we're going to change A to 30, just to show you that, yes, in fact, this does what we told it to do, right? So now it's going to say 30 is, in fact, greater than 20, right? This is all pretty simple stuff. But now, here's something specific I want to call out. With logic, it is explicit to what you've told it, right? Is A less than or is A greater than B, right? So what if they're the same? Now it's just like, well, it's not greater than or less than, right? So now I could change that output to say, well, it's probably equal to. But in that case, it's, anything that fails greater or less than will tell me it's not greater or less than, or it'll tell me it's equal to, and that's not necessarily true. So what we can do is add in another block here. Just going to go to the next line, and we'll do Elif, and then $A, capital A. And then there's another operator called EQ, -EQ, which stands for equal, right? We're going to close that block. Then we'll do $A and $B are equal. Okay, and then if that fails, it'll then fall to the else. Now, there's not many cases where I could think that, oops, I didn't want to vim that. I wanted to run it again. There's not that many cases where it would fall to the else. I must have typoed B. B is a very difficult variable to type. Oh, I did lowercase b. I am curious, folks in the chat, do you make all your variables in Bash uppercase like I do, or do you not care? Because I for some reason, a lot of Bash scripts, when I see them written, the variables are always uppercase.
So I actually explicitly always define my variables as lowercase, because then I don't have to worry about them conflicting with environment variables.
That's probably a good reason. Environment variables are usually uppercase. Maybe that's why some people have that habit, because the environment variables are uppercase. So that makes sense. Anyway, now this should work properly. Right. So 30 and 30 are in fact equal. Now, if I did something silly like change one of those to like letters instead of numbers, then I think this would break. Yeah, now it's like you can't compare that, right? Expression expected, right? Integer or expression expected. So let's change that back to a number. Okay, now we can also check. This is very simple, right? Are numbers different? And that's actually pretty valuable in a lot of cases, right? In Scott's example from earlier, maybe we're pulling in that disk usage number, and then we ask Bash, can you tell me if this number is greater than or equal to 90, right? And in which case, then you should alert me, or 80, right? I guess your example was 80 to 100, right? But what if you, say, are writing a Bash script that is meant to write out to a file? or perhaps to a directory, but we'll talk about that in the next example. What if you want to write to a file? What if you want to make sure before you try to write to the file, does that file already exist? Maybe if it doesn't exist, you want to create it. Maybe if it does exist, you want to make sure that you back it up or you don't overwrite it. Or maybe you don't really care and you just overwrite the thing. So we're going to uncomment this block here. Now, there's another operator called -f. And it doesn't, so a lot of these things have two things on either side of the operator, right? In this case, it doesn't require a thing on the left-hand side of the operator because it's simply saying, does the thing in this variable constitute a file, right? And then we have another block after this that checks, there's another file that I have defined. Does that file not exist, right? So we're going to run this one as well. Okay, and so the first thing that we checked for was etc password. And of course, file exists and it's a file because that's what the -f operator does. It doesn't just say, is there a thing in the file system called etc password? It says, is it a file, right? Now, what it didn't do is tell me anything about whether the second item in that array or the second item that I was checking for did or did not exist, right? Now, there's a couple reasons that it could do that. So first of all, let's go look back at what we were checking for. That was file 2, and that's etc foo. I can tell you that etc foo probably doesn't exist, but we can go look just to be sure. And in fact, etc foo does not exist. So why did it not tell us that it didn't exist? Because that's exactly what we're checking for. We said, see here, I said elif bang at the beginning of this operator says reverse the operator, right? So -f says, does it exist? Bang space -f says, reverse that. Does it not exist, right? So in this case, it should be checking, does file 2 not exist? And if it doesn't exist, it's supposed to output this thing here, right? But it didn't do that. So Scott, you have an idea why it didn't? I know exactly why it didn't, but I'm going to quiz you now because you do this to me all the time. Make sure I'm paying attention.
So when you do have a nested conditional structure like this, at the first true match, we stop checking anything further.
Right, right. So if the first one were to have failed, if etc password did not exist, our system would have problems to begin with. But if it did not exist, then it would have moved on to the else if or the elif, right? And again, most programming structures have an if else if sort of structure that you can check for in case you want to check the existence or not existence of more than one thing at a time. So what we should do here is instead close this if, or go with, we could close it with a second, with an else instead of an fi. That would tell it if this fails, then go on to print some default output, right? But in this case, I'm not going to do that. And the way you close if is with it backwards, fi, right? And you'll see that in a lot of logic in Bash. The thing spelled forward will open it. The thing spelled backwards will close it. Unless it's using a do and done block, which I'll show you when we go into loops like for. Okay, so now what it should do is it'll check this condition and then exit this particular if, and then it'll check the next condition. Oops. Okay, so now it actually did what we told it to do. It checked for etc password, that existed. It checked for etc foo, that did not exist, and we output the proper output for that. Now, like I said, go ahead.
I was just going to say the elif syntax that you were using before is really handy when you have like several conditions that you will accept, but you don't know which one of them it's going to be.
Right.
So, and there's another syntax that does something similar to that too, right, Nate? But it's not if, it's a case.
Oh yeah, well I didn't have time to write up a case statement. Case is one of those things I didn't use a whole lot in my sysadmin days, except for writing init scripts. Since I don't have to write init scripts anymore, I almost never have to touch case anymore.
And so if elif else and case work the same way, where like you come in, there's a series of options, And
Right.
if you match one of those options, you're good. And it'll stop checking at the first match of option.
Right. So case is really good for a thing where you're going to, like, imagine an old school init script. You might tell it start, you might tell it stop, you might tell it to reload, right? You'd have a case statement that has all three of those as options in the case statement, and then it'll match on whichever one you entered. So if I said like service start, service stop, it'll match on, okay, what do I do when you've told me to stop? I think your example from earlier where you were talking about memory or SELinux status, or what was the other one? Disk space usage. You could have used a case statement there that said, if you match one of these things, report that one. But it wouldn't do more than one at a time. It would only do one of them, right? So, all right. So, but yeah, you could do that with some crazy convoluted if structure instead, which is nice when you have options, right? Okay. Okay. So the last example here for if is really just like the file example, except now we're checking for directories. Remember I said earlier that the -f operator only checks for whether it's a file and whether it exists. The directory operator does pretty much the same thing, but I threw this one for a little bit of a loop, right? We're going to show you how I defined dir1 and dir2. dir1 is /var. We should know that is going to exist. The dir2 I actually pointed to a file. So what do you think it's going to do, Scott? Do you think it's going to return true or false? I kind of already told you the answer, didn't I?
Well, it's a not directory, so I think it's going to say that is correct. It's not a directory.
Right. Right. So it is a file that exists. It's a thing in the file system, but it's not a directory. So now if we do if example, we should see that that is true, right? So you can see it says var exists and is a directory, and then etc password does not exist or is not a directory, right? And that's my own output, right? I could just say, oh no, it doesn't exist. But if you're actually testing whether a thing exists, whether it's a file or a directory, I think there's another operator that'll just say if there's a thing on the file system. I can't recall exactly what that is off the top of my head, but if you didn't want to do it that way, you could check if it's a file or a directory by doing -f and then -d.
I think it's -e. It exists.
Exists. I think you're right. I think you're right. We could try it quick.
Yeah, and just so
Let's
you guys
go off
know,
script.
Nate has a bunch of these test operators. There's ones that say, is it readable? Is it writable?
Yes.
Is it executable? Like there's all kinds of these small test operators that are built in.
Right. So my logic was saying, does it not, like, because I had, if it's not a directory to return, right? So now I changed that to -e instead of -d, which is what we think does exists. And sure enough, it doesn't tell me that etc password, it doesn't tell me anything about etc password. But if I go back and take away that bang, then it'll tell me, does it exist at all? And
it does not exist or is
well,
not
that's because my output was wrong.
Yeah.
Ah, I did DD on accident, trying to rush. Ah.
Typos.
This is what happens when I try to rush in Vim. Okay, there we go. etc password does exist, but it doesn't test whether it's a directory or a file. It just says, yes, there's a thing there, right? And you should not try to overwrite that. So important clarification. All right, any questions about if that we should talk about before we go on to while? Or sorry, for and while.
Yeah, one of the things we didn't check, I know that we used the numeric operators of less than or equal. One of the things that we didn't do is string comparison. So a lot of times, my scripts, I'll like run a command and look to see if a word came out of that command. And if it did, that's when I want to do something. Or if it didn't, that's when I want to do something. And so for that, there's
is it just equals? Yeah,
equal.
Yeah.
That is the string comparison to say, take this string on one side and compare it with the string on the other side. There's also a string less than and greater than, which might be interesting, but realize that what does it mean for a string to be less than another string or a string to be greater than another string? So
yeah,
depending on your usage, that could or couldn't be interesting. And Nate, A and B are numbers in yours?
I'm working on that.
Okay.
I just picked 2 and decided we're going to change them. So now if we change this one, like if I make them, strings and run it again, now it should say that they match, A and B match. And then if I instead change them to like foo and f, it should come back and right. So I didn't put an else in there to say it didn't match, but that's how that would work.
Yeah. And the other thing to keep aware of with string operators versus numeric operators, if you accidentally use equal equal in comparing 2 numbers, which is like a reasonable mistake to make.
Yeah.
What you're actually doing is comparing the character by character value in the number to one another rather than the actual overall number. So you could make it so that 30 and 4, it'll say that 4 is bigger than 30 because the character version or the character 4 is larger than the character 3, not looking at the entire number. It just does a character by character.
Yeah. Yeah. I'm trying to find one that makes that return true, and it's not working for me here, but
just be aware that when you're using comparison operators, choose numeric operators when you're comparing numbers, choose string operators when you're comparing strings.
Yeah, other languages are usually a little more forgiving about that. They figure out if you're trying to compare a string versus an integer and they do the right thing. Bash doesn't always do that.
Yep.
One of my favorite things to use interactively at the terminal that is also used frequently in a bash script would be a for loop. And I got in this habit way back in my systems administration days. The first time I saw a for loop in action, I'm like, I do that all the time. Anytime I need to do something more than once in the console, I figure out a way to do it in a for loop. So I don't have to type a command twice, right? So you might say, what's a for loop? So a for loop is basically take this list of things or this array of things and do the same thing on every item in that array, right? So if I do like for I, type out for properly. And I don't know why, I always use I. But we can do like an array of numbers here, right? And close the parentheses there. And then we do, which says do this thing with all the things in this array. We're just going to do echo $I, and then we're going to do done, right? And the only reason I'm using all these semicolons is because I'm stringing this all together on one line. These are actually, if you were putting this in a script, you would normally break them line by line so that it's more readable. You could do it like this in a script if you really wanted to, but why? It just makes it harder to read later. All right, so now this should just count from 1 to 10, but I could also do stuff like, I don't know, let's echo that into a file called $i.txt, right? And sometimes I'm going to clarify, right? Sometimes when you combine the variable with other text, it's good practice to qualify the variable name, right? In this case, I don't think it's going to hurt me, but in a lot of cases it will. And one way to do that is with these curly braces. There's probably a bunch of other syntax that I'm not talking about here that you could use to protect your variable names, but this is the one I usually use and it works out pretty well. Now, if I look, I should have text files 1 through 10, right? And the other cool thing with a for loop is you can take input from bash and pipe and make that the thing that the for loop acts on, right? So if I wanted to do something like, we think of a good example here. If I did for I in, and then if I do the backtick and then a bash command like ls star.txt, that'll return a list of all the .txt files in this current directory. Do, I don't know, we can just do ls-l $I, done. And then there you go. Now, obviously, that's very much like if I just did a directory list thing, but you get the idea. What this actually did is it executed ls-l on each item in that array, right? Because we have it knows the file is there because it passed it in through the for loop. This is great for what if there's something I wanted to do to each of those files, right? I could use a for loop to say find all the files that match this bash syntax thing that I threw together, and to do this thing on those files. Maybe I want to delete them. Maybe I want to add something to the end of them. Maybe I want to change ownership or permissions on them. I don't know. Maybe I want to move them somewhere. And it's just not as easy to do a wildcard or something to execute the thing. So this is a good way to get that additional power out of bash. You could do something like, well, I would have wanted to have cooked up a better example instead of fumbling around with bash right now, but you can do something like use grep to find a string of text in all the files in your file system, or use find to return all the files that match a certain thing, right? And then pipe all that into your for loop and then do something on all the files that it found, right? So really useful stuff. But I do have an example of how you'd put this into a script. And it's really simple, right? In this case, I just did pretty much exactly what I just showed you at the command line. If I do a for, I used n in this one because I felt like changing it up. 1 to 10, and it'll do a thing. In this case, it'll just echo out, right? Because that's the easy thing to do, right? And that's exactly what we just did. I tried to make an example where I read in start and end, which I'll show you in a second here. But the problem was I couldn't get the syntax right for this line where it says for 1 through 10. If I just substituted the variables in there, I could not get this thing to execute. It just didn't treat the variables properly. And the fix I found for that was this. You can use this other command called sequence or SEQ, which I think is the expansion of those curly braces, right? So
no, sadly, the curly braces is like its own implementation.
Okay.
And sequence is an actual command, whereas curly braces
there we
is
go.
like an internal bash thing.
Right. So at any rate, if I tried to put variables inside of the curly braces, if I did it on the command line, it worked fine. If I did it in a script, it did not. I can't explain why. But if I do it this way and I just change that to sequence instead of to, and again, this dollar and then open parentheses is actually telling bash, go run this other command and put the output into the for loop. Right. So it's essentially what I just showed you on the command line with that ls example. So now if I save this and then we run the for example.
That subcommand is called quoted execution. And the other way that people often implement it is with enclosing their command in quotes.
Missing operand. What did I get wrong? There's supposed to be dots in between these? No?
Nope. Can you?
I don't know what went wrong. It says it's missing an operand.
Oh, you forgot to pass it start and end values.
That's these right here.
Yes, but on your command.
I see. That's why. I got ahead of myself. All right. So if I do for example, and then that's right. I wanted to show you the command line input. That's the whole reason I did this. If I did 1, well, let's pick different numbers. Between 20 and 200. There we go. Now it did the thing. So there we go. That's how you can put a for loop with input if you needed to inside of a script. What were you going to say?
So go back in and show the quoted execution again. So I mentioned that some people will also implement that using back quotes, right? Which share E with the tilde. That is not a recommended way of doing it. Because not every keyboard has an easily accessible back quote.
Yeah.
And things like Nate's copy and pasting from Google Docs, right? Google Docs do not.
Google Docs are terrible with backticks.
So dollar parenthesis is
Right.
an easy to use or easy to find key combination on many keyboards, even international ones. And you don't have to worry about horribleness of copy and pasting between things like you do with back quotes.
Right. I got in the habit a long time ago of using the backticks, and I think it's actually come up on this live stream in the past where people are like, backticks are terrible. They always work for me. But yes, dollar parenthesis is another way to do it, and I guess better in everybody else's opinion except mine.
Yeah.
That's why we do this on the internet, so people can give us their opinions.
What is it? If you want to find out the correct way to do something, say the wrong thing on the internet?
Yes. Yes, that is the right way to do it. Say the wrong thing on the internet, you'll get all the engagement. All right, I have one more example. Hopefully it won't take too long because we're almost at an hour. Man, who knew beginner bash scripting could be so all-encompassing? This one's actually pretty easy. While is another loop structure that is helpful in bash. And what this does is it's similar to for, except it's more about while a thing is not true, do this other thing, right? So it's really good for if you're reading in a file, like while there's input, do this stuff to the lines you're bringing in, or while something is true, well, it's what I just described. While something is not true, then do this thing, right? So I should say while it is true. So in this case, I made a while loop where I've defined a variable for C, which is count, and when I want it to end, which is 100, right? So what this should do is while C is less than 100, and this is the exact same syntax here that you'd use with if, right? The -le. Well, actually, LE is one we didn't cover. LE is less than or equal to, right? Whereas LT is less than. This is less than or equal to. So as I go from 1 to 100, I should hit everything until I get to 100. If I just did LT, it would stop at 99 because then it would no longer be less than 100 when the number is 100 because that's actually equal to. And then we're just going to echo the number. And then this is a special command that increments C by 1. It just basically says take whatever's in C and add 1 to it. So if I did while example, we should get, there you go, 1 to 100. So what's your favorite use for a while, Scott?
Oh, I use while true when being horrible.
Yeah, when we're trying to tax a system to show you something else. While true, do something horrible.
No, usually it's when I know that there's going to be a condition change on the machine, right? So I could say while the condition doesn't exist, keep doing the thing until that changes, and then it can drop out.
Or you could like fill a hard drive by saying while the output of DF is less than 100, keep doing this thing to write data and have it stop when it gets to 100. Of course, it'll stop anyway when it gets to 100, I guess.
Right. But if you wanted to not fill it all the way up, but fill it to like a certain percentage, you could do something like that.
Right. So just imagine that, you know, this C++ would be a thing that I'm doing on the system that would change its state, that I'm waiting for another thing to occur, right? And the thing that I'm testing for would be, has the thing occurred yet, right? So maybe there's some crazy bash foo you've thrown in there that says, is the disk at 90% yet? And this thing here is, okay, write another 2 gigabytes from dev random into a file, right?
Today, we're going to talk about manipulating the CLI. My name is Eric, the IT Guy Hendricks, and joining me is my lab extraordinaire, Scott McBrien.
Good morning.
So, Scott, I'm really excited about this week's series of episodes because we're kind of diving in layer by layer into the command line, into the terminal, into the guts of this thing, leading up to probably a pair of episodes over the next couple of weeks about writing bash scripts. So I figured we'd start today with a quick review of a couple of the commands that we looked at yesterday. So kind of putting the pieces together. So if you missed episode 16, highly recommend you go back and take a look at that. So you may remember that we introduced the grep command, which is basically pulls certain text out of files. And we ran this command of we grep for bash out of the etc password file, but we didn't want... But we also added the $sign to ensure that was the only text that we got was bash and not like bashy or no bash or something like along the, I guess bash no. Anyway, bad example. But we use the $sign to say that we just want the word bash. And then we also introduced the pipe command, or the pipe character, which we'll get into a little bit more today. And then we also introduced how to use the cut command to pull certain columns based on different delimiters. In this case, the etc password file uses the colon delimiter, and so we wanted to pull out columns 1, 3, and 7, and then another pipe, and then we also introduced the sort command, which in this case is going to sort our results alphabetically. So what that long, messy command is going to do is it's going to pull out any lines that have the bash, the word bash in them. We want the first, third, and seventh columns, and then sort the results alphabetically. So we see that we've got the root account, we've got the RHEL service account that we've been using, as well as a few other systems accounts that have bin/bash, and that's what we're going for with this command. Scott, do you want to expand on the results any?
Yeah, so just one point of clarification. The $ in our regular expression for bash, that matches the end of line character. Bash, or I should say regular expressions, do have a word marker as well, so you can pull out things that are delimited by spaces, tabs, punctuation marks, but we're not using that. We're using a $, which denotes end of line. So we're looking for things where the line ends with the string. But yeah, what we're doing here is we're just passing input from the first command into the second command so that it will execute based off of that input, right? So if we break it down step by step, right, we get our output of bash or our grep, and then that's going to go into we get our unsorted list, right, where it's just based off of its content in the file. And then lastly, we send that cut output as input to the next command in our pipeline, which sorts it, right? So at each stage of our piped command, we're taking output from the previous command, then manipulating it in some way, and then passing it as output to be input to the next command on the pipeline. And so you can get like really complex operations by tying this string of command skips. And Eric, you want to do another example? Actually, I probably don't have this one installed. 1 second.
That's okay, because I was muted anyway. So there's on our
RPM that provides us the next command that I want to use.
I think that harkens back to a package management episode we did a while back. But so there is a tool on our system called IOstat, and that has to do with actual disk performance. And so that's read and write speeds, that looks at queue depth for what is being written to our disks or being read from our disks. So this is good information to have if you're doing very heavy read and write operations across, say, a network file share, or if you're pulling in lots of information from different sources onto a server and you want to see how your disks are performing. So the IOstat command, Scott, we've got the -C option. You want to talk about what -C means, and then we'll get into our pipe?
Yeah, so sometimes we can use things like grep and tools like that to pull out stuff out of a command output. But a lot of times the commands themselves will have things to limit the output. So if we instead run iostat-c, right, we only get the CPU line and we lack the disk information. And then, but notice that we still have a header. And so what we might do if we're only interested in that CPU utilization is maybe we take that smaller set of output from the iostat-c and pipe it into something like tail, which will show you the bottom part of an output. And I'm telling it to show me from line 3 and below. So everything from line 3 is what I want printed out of my tail command, right? So I'm only able to isolate that segment. And in fact, we could do a little bit more because there's some white space there. Maybe we then pipe it to a head -n2 that says only give me the top 2 lines of the output, right? And then we'll be able to like slice down what I'm looking at. So this is an example of like taking our text tools, again, sending output from one as input to the next to then further refine what I'm getting out at the end.
So a lot of times you'll see the tail command used when looking at log files. So you only want to see the last so many lines, whether in this case it's 3 lines. That way you can see the most recent entries into the log file without having to command into a full text editor and scroll all the way down, because then the text editor isn't showing real-time changes, whereas if you run the tail command, you can go ahead and see those. And then the reverse of that, like Scott mentioned, was the head command, where we want to look at the top so many lines of a file. And so it's amazing that the pipe command can actually take seemingly opposing commands and put them together, because with this we could actually create a text file with historical information. You could use like the date command to establish when a command was run and have that command run every 5 seconds, every minute or something, and really track the performance over time. And all you're doing is using IOStat at the very base of that command. What if we're running a command and it gets an error? And a lot of times it'll give us what we call a return code. There's different return codes which mean different things, like a return code of 0 means a success. Different return codes mean different things with different applications, but we can actually pull up the return code from a command using echo, for instance.
So let's say instead of this previous command that I ran, I went in. So clearly there is no Eric is the best option to IOStat. And what we get is an error message. I know. But here we actually get a message that says IOStat in the name, which is helpful. But depending on what your error might be, like where did it come from? Which of these commands that we piped together did it come from? But also, more importantly, if we do a echo $, we'll see the return code that was set when the command that failed. When you are a programmer, or even working with things like shell scripting, if you encounter an error, you can terminate the program and send back a code to indicate what the problem was. Not everyone does this, but we can see that here when I look at the return code from the error message that I got, it is 2165. And somewhere in the source of IOStat, we could probably figure out what error code 2165 applies to. But if I run it without a problem, and then I look at the same return code, oh, that's interesting. Not what I expected at all. Let's try one more time. Okay, so that is coming out of IOStat. Interesting. How will we do this? Oh, there we go. So I made a mistake and I got an error message. I don't know. Oh. Sorry. I think I'm doing something dumb.
Don't worry, folks. We are professionals.
Oh, gosh, I am doing something dumb. Because I'm using the wrong variable. All right. So let me reestablish this. I don't want $. I want $?. So $? is the return code variable. $$ gives me the process ID of my currently running shell, which is why I kept coming back with 2165. Fun times.
That still doesn't give us the output I would have expected because IOStat threw up an error and it's showing us a 0 code.
So let's see what happens if I do this. Right. So
okay, because it was reading the pipe command.
That's right. So with error codes, 0 means everything operated as expected, which is why up here when we did our piped command and we looked at the return code and it came back as a 0, both Eric and I were like, that's unexpected. Whereas down here when we run it just the command by itself, it got the correct return code. So I have a feeling that has to do with how we do return values. So it turns out this $? is set every time a command exits. So we did a $? which showed me the previous command's exit code, which was this error from IOStat. But if I do it again, it shows me that everything is fine because now it's showing me the output of this echo command, which successfully printed the exit code from the previous command and then closed. So you can only look at the return code once, right? And after that, it gets reset to whatever the most recent command is. But what's interesting is you can make choices based off of that return code. And I think we'll get to that in the further, deeper dive.
Okay, so we've looked at return codes. We've looked at the tail command, the pipe command, cut. sort. So if you check the show notes later on today, if you're catching this live, we'll have a list of commands and some additional resources that you can look at. Because like yesterday, we're going to throw a lot more commands at you today. But we're just working on building up that systems administrator toolbox. And another command that we can use to manipulate the terminal is the T command, Tee. And Scott, no matter how hard I tried this morning, I wasn't sure how to explain this in a concise manner.
Okay. Well, let's see what we can do here. So let me pull up this big list of stuff. Actually, yeah, that'll be fine. So the T command is a command that we can stick inside of a pipe. And think of it like plumbing, right? If you have two pieces of straight pipe joined together, what flows out of one flows as input to the next. And that's what we've set up here. But if you use a T-joint where there's a straight through, but then also a dropout, some of your data drops out or some of your water will drop out into the dropout, and some may be passed to the next pipe as it continues. And so that's essentially what the T command does. So we can drop in a T somewhere, and T takes a file as an argument. So let's do, and what it's going to do is we're going to run iostat-c. We're going to pass that as input to tail-n+3. Then we're going to pass that as input to T, which is going to drop a copy of what it received into this file. And then it's going to pass what it received onto the next command in the pipeline. And what we end up getting out of this is ultimately the output from our pipeline, but we also get this file created for us. It was a snapshot of the output that it received over the T command line. And so let me do something similar up here. I'm just putting files in temp because I don't want to keep them. I'm using them as an example. And if the system were to remove them in 10 days of inactivity, that would be fine with me. All right. So we're going to grep for lines that end in bash and etc password. We're going to pass that to T, who will dump it into this file in temp, and then pass it on to cut and sort. Right? So what we get out the other side is our fields 1, 3, and 5 sorted output of those users that have a bash shell. But we also get this file that was the unsorted, uncut output. And so this is really handy if you have written this big, long piped command and you're getting stuff you're not expecting at the end. You can drop a T kind of in place throughout the command to figure out where the output is getting manipulated in a way that you don't expect by the next command in the pipeline. So it's really handy for something like that. Earlier in, I think it was episode 1. I remember way back to episode 1. Okay. Well, sorry, it's suspect. I mentioned about creating a randomized password for someone when we added their user account. And I said that we'd have to make a copy of that, right? So the expect programming language gave us this command called mkpassword, which makes randomized passwords. So if I did an mkpassword, type into password standard in on the RHEL user on this box. Great, it set the RHEL user's password to a randomized string. What is that randomized string? And how do I give it to the RHEL user so they can use it to log in? Right? So here is another place where we could use a T. Right, so we made the random password, we dropped a copy of it into this file in the current working directory, and then we passed it on to password who actually set it for the user. So now if I need to send that user an email activation or something, right, there's the password that was set for them. And when I rerun this command again, right, every time you run mkpassword, it makes a random string. So now I have a copy of what that random string was set to. All right, and this is where T is kind of handy, is inspecting what's happening in the pipeline at a specific time, or
so
saving a set of output at a specific time.
I can think of a couple of good use cases for T. Like you said, from a troubleshooting perspective, to be able to output information as we go, or in the past, I've had to pull logs or run user reports, things of that nature. And of course, each team wants their output formatted differently. So you could actually use the T command to maybe group A needs it in this format, and so you could T that output out. But maybe the next team only needs to know like what users are actually on the box. So you could pipe a series of commands together using the T command and kind of in one pass get everyone the output information that they need. The other would be if you're running bash scripts that you want to track the output. So a lot of times I would write a series of commands into a bash script to clean out my DNF cache and rebuild that cache, and then do like a kernel update and then a security update and then an all update. But I'm not going to be there interactively to watch the commands run. So I still want that output. And T's one way, maybe not the best way, but T's one way to get that output available. But I did want to back up to that previous command where we introduced a new option, and that's the standard in. And it's almost as if we plan these things that we talked about T and then standard in. So what is standard in, and how can we use that?
Yeah, so normally when we run the password command, it prompts me for input that I type into the keyboard, right? So the normal place that utilities expect input from is the keyboard, right? And we call that standard input. But you may want it to pull input from somewhere else. So instead of using the keyboard, we could pass input via a file. Password is kind of a weird one because it has this option that controls where it looks for standard in. But a lot of times we'll have something like, hey, you of course chose to start with the hardest one, Eric.
I did nothing of the sort. You're the one who typed the command. I just went off your lead.
All right. So it's maybe something like this, where usually do that either.
You're more than welcome to back up and take this from a different angle.
Yes. So let's put a pause on standard in, because I think that's the hardest one to understand. And instead, talk about some of the other standard I/O channels, right? Which is what I was hoping we would start with first. So there are three standard I/O channels. Standard input, which we briefly touched on and we'll come back to. Standard output, which is where output from commands is sent. And standard error, which is where error messages are sent. So if we do something like rep hash dollar, let's see, password. Right, we have that message, that output, printed to the screen. But what if we didn't want it to go to the screen? We want to store it in a file. So we could use this greater than redirect operator to say, take this output, and instead of sending it to the standard place, which is the screen, send it to this file. Right, so we've captured that data in this file now. Right? If I take a look at it, that's the output that previously was going to the screen, the standard place. And now we're taking that standard output and redirecting it to somewhere else on the screen. We have a similar redirection operator used for error messages. So if I use something like find, I look over the entire system, something named www. So I get some error messages, right? Find is saying, oh, I can't look at this proc file. And if I was to do this as a normal user, I get a lot more error messages because normal people aren't allowed to go all over the entire system like root would. But then I see this one actual output message. So if I wanted to suppress the error messages to keep them from going to the screen, I can use the operator to greater than. And a file name. And instead of sending those error messages to the screen, they go into this file. Right, so if I do a cat on find errors, that's all the error messages that were captured in this file. And for error messages you don't care about, like maybe these, because we expect them to come up because as a regular person, I can't find everything over the entire system. Maybe I redirect them to a special device character or device file called Dev Null, which will accept any input it receives, but actually not store it or reflect it, right? So there I just kind of throw away all those messages to Dev Null. We could do both. So here, I'm going to look over the entire system for file name www, and then I'm going to send all error messages that I might get while running this command to Dev Null, so they're just lost because I don't really care about them. And then I'm going to take all the output that I get from this command, and I'm going to put it in this file called filenames. Right, so because I've redirected both errors and output, I get nothing from the command. It's silent. But if I actually look at the system, there's the output that it was captured that was redirected into my file. So pipes actually work in the same way. So if I find these files, and I don't remember if ls will take input over a pipe, but we'll try. So it's going to find the files, throw away the errors, and then the output from this command, instead of being stored in a file with that greater than redirect, it's going to be passed as input to the next command. Yeah, it didn't work. Nope, that's not going to work either. ls is a bad example. How about we type it to do that either. RWW is not really what I want to do either, but it works. So it takes the output, then it passes it as input to the next command. So cat prints something that it gets, and so that's why I get stuff printed to the screen, which really isn't any different than find, but
Could do
I'm struggling
like
to find stuff.
ls, like an ls-lz or something, if we wanted to.
So ls doesn't take input over standard input.
Oh, that's a good point.
Right, and so that's why I was struggling with that one. So you see up here, it actually just ran ls and showed me the current working directory's contents. So anyway, redirecting output can be hard, or input into the next command can be hard, but that's what pipes exist to do. Take output from one command, pass it as input to the next command on the pipeline. And then some commands like ls aren't going to support that, or password, for example. Right, so if we just did this, that is root. Right, so traditionally we would say it would try to set the password to /var/www, right? Except you'll notice there's a bunch of errors that come out of the password command. And that's because password by default doesn't accept standard input. So that data that it's getting over the pipe is refused. And hence why we get that error message, which is why we had to use the special option that say, hey, password, you need to accept that input over the pipe. You need to accept input through the standard in channel that you're getting from the pipeline. Right, and now it actually sets the RHEL user's password to /var/www, which would be an interesting password.
I don't know that many people would be able to guess that. So to recap, standard in defaults to the keyboard, but in the case of, say, the password command, we can actually suggest commands accept input from other places for that input. Standard output is just the return that comes from your commands. So if you do an ls, or if you do a find command, the standard output is what it returns. The standard error is anything that's not a standard output. It's anything that's gone wrong anytime we have permissions. And we can take standard out and standard error, and we can take them and redirect them wherever we want. A lot of times that might be a log file or something that we might specify. Or in the case of pipes, we may redirect output or error into a pipe to do something with that information. And we'll see tomorrow when we start talking about shell scripting that you can actually take the return codes or the standard error, and if a certain error code is found, you can actually do certain things with that information, versus if you had like a 0 return code, if everything went successfully, you could do a different list of things, and we call those if then or if then else statements.
So we do have one last thing to cover quickly, because I know that we're running out of time together, and that is the difference between overwrite redirection operators and append redirection operators. So here we ran this command and we generated our bash users file. But what if I change it a little bit? And I now look for the string root, and I redirect the output to the same file. Before, I had a list of all the people that had the bash shell as their logging shell. But now it has the list of people that have root somewhere in their password line. So the redirection operator we're using of that single greater than is known as an overwrite operator. It will destroy the contents of the file that was previously there and overwrite the file with new contents from our command. So if we really wanted both pieces of data in a file, so I've already got the root user information in there. Let me change it back to look at my bash information. And I'm going to change the operator instead of a single greater than with double greater than. A double greater than says, take the output from this command and append it to an existing file. And if the file doesn't exist, it will create it and put the output in there. But if it does exist, it'll leave the content of that file in place and then add the new output that we're redirecting to this file at the bottom. Right, so when I look at the file now, here's the 2 lines that were already in there for when I grepped for root. And then here's the 7 lines that I got by grepping for people with bash as their login shell. Right, whereas before when I used the single greater than, it overwrote the file with just whatever the content of the command was being sent to it. And we can do that with error messages too. So I did that as a regular user. Hold on. Well, okay. So before I did this command where I redirected the error output for finding this file to a file called find errors. And if we take a look at it, there's all the content. And if I do another command, this overwrites the file that I created right here. Notice the 2 greater than overwrites the find errors with the new errors from finding files named RHEL. So if I wanted to keep both and append them together, I would use 2 greater thans, right? This changes my overwrite error redirect to an append error redirect. And what I should see after this is a bunch of error messages from trying to find files named RHEL, followed by a bunch of error messages trying to find a file named www. All right, so let me do those one more time. And we will do something a little bit different to look at it. All right, so there's redirected. I got the file error messages for RHEL, and what I'm going to do is a word count. Right, so we saw 925 errors currently in this file. And if I redirect without the append, I should see probably roughly the same amount of error messages in this file. Because it hit the same directories that it wasn't allowed to go into for the second find. So now if I change it to a redirect, where I'm keeping the file content in place and then simply adding new errors at the bottom, what I should see is when I word count this file, I should see twice 925 errors, right? So I kept the errors from my earlier find, and then I appended onto that the errors from my second find and kept them in place. There is one other weird redirect operator. And greater than. So before we were looking at redirecting output and redirecting errors, and you can sum the different places, but ampersand redirect or ampersand greater than says send both output and errors to this place. Right? And calling it find errors is probably not a great file name. But when I'm looking at it, I see a bunch of error messages, and then eventually there's 925 messages in here. There we go. I start to see some of the output that was printed by the command. And because I redirected them both at the same time, I get to see them in context. So when I separate them, I see all the errors in one file, all the output in another file, or all the errors in one file and all the output to the screen. When I ampersand greater than, I redirect them both as they occur into this file. So when I'm looking through the file's data, I can see a mix of error and output files, just like I would if I ran it on the command line.
So I can attest from years of being a systems administrator prior to this, the standard input, output, error are much easier to use than they are to explain. It's much easier in context. So if you're running a web server and you're getting permissions errors, it's much easier to use standard output and standard error in that context than it is trying to explain in kind of a vacuum. Today, probably one of the most complex and crazy but powerful tools that we can add is automation. And that automation is through shell scripting. So today we're going to start out writing a very basic shell script in the critical path, and then in the second part of the episode we're going to make an interactive script that's going to ask users about what information they'd like to share, and we're going to have a script do a certain thing based on that response. So why don't we start out with how do we write a shell script? So for the most part, you want to... Yeah, go ahead.
I was just going to say, it's important to note that a shell script is simply a collection of commands that should be executed in order.
That's a great point. And as we're going to create a shell script, why don't we write, we can do a VI or a vim on, we can give it a brilliant name like MyScript or something along those lines, and then we're going to use the .sh extension, and that's short for shell. So if we go ahead and VI, and then in VI, you need to use the I key to enter insert mode, which is what allows us to actually type into the console or into the file we just created. So when we start, we need to define what shell that we're going to use for our script. In this case, we're going to use bin bash. A lot of times, it's good practice to get into on the second line of your script file to put in some kind of a comment, something that tells both yourself, your future self, or other admins who wrote it, what the purpose of the script is, any documentation you might have cited, maybe a last edited date, just different information. And you can do that by starting each line with an ampersand or the pound sign, or to some of the younger generations, the hashtag. So whatever you want to call that, the tic-tac-toe box, that tells the interpreter to ignore this line of text, that it's called a comment. So it's good to put some information like that into our text file. So we've got our shell, we've got a comment telling us what this file is, who wrote it, other information. So let's start out very simply here, and let's do an echo command. The echo basically takes the output of a command or just text that we put inside of quotation marks and prints it to the screen. As we mentioned yesterday, echo actually, by default, posts text to standard output. So if we run the script, we'll actually see that it will print the words "the time is currently." So next, let's use the date command, and that'll give us the time and date currently. Scott, what else should we have our script do?
Oh, why don't we have it just give some system information? So we've used iostat a couple times, and maybe your favorite, 3-H, to look at the used memory.
I used -H the other day instead of -G. I was proud of myself. So this gives us a good output. This is kind of the foundation of some basic information of time and date and the actual health of our system. So this might be good to run when you first log into a box just to get a feeling for what's going on. So when you're using VI in insert mode, you have to use the escape key to leave insert mode, and then you use a colon to define that you're going to give Vim a command, and then we're going to write the file, and then we're going to quit the file. That's what the $WQ means. You can also use $X to do a save and quit. It's the same thing, one less keystroke because I'm lazy. So let's go ahead and write and close out our file. Now I should just be able to run this command, right, Scott?
I mean, we could try, but I think it would fail.
Actually, let's do it. Let's run our script as is. Let's see what the output is.
Well, notice my tab completion won't even find it.
Mm-hmm. So in order to fix that, what we need to do is, if you look back to, I think it was episode 2 when we talked about file permissions, notice that there's no X in our file permissions. So there's no execute permissions on this file. So let's go ahead and do a chmod to change mode, and let's do, an A plus X works. And now tab completion worked. So now if we do an ls-l, you notice that the color changed and our user group and other permissions now have execute. So then, harkening back to that file permissions episode, we can actually execute, which, in other words, we can actually run the script now. So if we type my script into the command line, notice that it's still not working.
It is not. Oh,
so you might have to do a period / and then my script.
That'll work, and we'll actually cover that in the deeper dive, I think. There we go.
So notice that it says that the current time is, and then gives us the date and time. We've got our iostat output telling us about CPU and disk performance, and then there at the bottom gives us our free memory information. So that, in just a few minutes, is a basic example of a script file. And for the most part, when you start writing shell scripts, that's as simple as they'll be. And you'll see it over time as you run into weird errors, or as you realize that you need additional output from your shell scripts. You can just build on top of them. And it's good to write something very, very short, test it, add in some new functionality or a new command and test it. So it's one of those things where if you just take a step back and build it in iterations, shell scripting is actually a lot easier than it's made out to be. So Scott, what else should we add to our shell script? Or better yet, how about we talk about how can you run a shell script without having to be in that same directory?
Yeah, so I think what we want to look at first is the path environment variable for this user. I'm going to do an echo $path. And I see the problem. So 1 second, let me do one thing. Okay. So you'll recall from previous shows that there's like a little bit of weird environment setup for this box that I'm using as our example. And what I noticed and what I checked was the environment variable that tells the shell where to look for executable commands. And what was missing was this shell, which is or this directory, which is where I had put our shell script. So now that the path environment variable has the right content, right? If I run my script, tab completion works, it finds it just fine. And it turns out that this directory, your home directory and a subdirectory called /bin underneath of it, is standard to add to your path for bash shell logins for Red Hat Enterprise Linux. So you didn't notice because we started it that way, but here in my home directory, I created a bin subdirectory. And that's where our script is. And when we log in, it'll automatically check there for executables, in addition to places like user bin or user sbin on the system. And this gives a great way for individuals for administrators to create their own small commands to do stuff without having to add them to the system directories, which would then maybe grant access to all the people in the system to do that stuff.
So if we were to navigate to, say, var log, so that we weren't here in our home directory and we were elsewhere in the system, we should be able to type myscript and myscript.sh and run our command again, and it would work. So having the scripts in one of those bin directories, a directory within our path, we can run it from anywhere within the system, which, like Scott said, is incredibly helpful as a systems administrator to have some of those customized command strings at our disposal, no matter where we're at in the system. So you used a feature within the terminal that we hadn't really talked much about. You did an echo $path. And what that is a path is known as a variable. And so anything with a $sign in front of it is a system variable. So I think a few of them are path, obviously. I think shell is one of them.
We could get a list of all of them with the set command.
That's right.
So it shows us our included shell functions, but then up towards the top, there's a lot of shell functions. Man, there's a lot of shell functions. And we've run out of rollback history. So how about I do a set less? Right, so there's our variables that we've got set.
Let's see. So yeah, if we do like a $bash, it would tell us that we're running the bash shell. If we did a $home, it would tell us where our home directory is.
Yeah, and ones that sometimes are weird. So for rows, how many lines? That's what it is. So columns and lines are the settings for how large your terminal is. So that's how tools like less know how much of a file to display at a time on one page worth for your terminal. There's another one, PS1. That's what's displayed as your prompt. Although this one has a whole bunch of color coding in it, which is why like that root at RHEL is green and the directory is blue, because it's got all these color codes embedded in my prompt variable.
Which, by the way, comes by default in most bash shells these days, which makes it really easy to see what and where you're working. So how might this apply to our shell scripting example?
So one of the things that we can do in our shell scripting example, let's see. Well, first, let's make a couple of slight tweaks.
So
harkening
we're going
back to our shows from just the other couple of days.
Yeah, so we're going to echo a blank line, and then we're going to tweak our IOStat like we did yesterday or the day before to just get some of the CPU information, and then another blank line.
All right, so here we're adding a prompt. Echo-n says don't print a new line after the query, so our cursor will be sitting just after the question mark space. And we're going to read a variable. Okay, so read is how we get data from the standard input, right, which would be somebody typing at the keyboard. And we're going to take that input that we get from the keyboard and store it in this variable reference. And then later on, we can use the content stored in this variable by referencing it with that $sign leading character. So when we say last, we see the $sign character, which says, they're going to reference a variable. So let me look up what's stored in the variable, and I'll substitute that on this command line. All right, so if I've done everything correctly, now when we run my script, we should see a little bit less IOStat data. We should see our free data. We'll see the date at the top, and then it should stop and ask me a question. And maybe I put in the RHEL user. And then it runs the last command, passing an argument of the RHEL user, and it looks like that person has never logged in. So let's change that. Oh, well, that wouldn't work very well. And that's not going to work well either. All right, let's see if that changed though. Script, RHEL user. Okay, so we still can't show them as a login shell. How about we do root? All right, so when we ask for the last login of root, it looks into the wtemp, which is a log file that tracks people's logins and is able to find the last login for that person that we passed in. All right, notice that my input is still a little bit messy, so let's go back in and I'll just put in a little bit of another blank line here and blank line there. And maybe we should clean it up a little bit more. Like, do we care that the wtemp belongs at this or started at this time? Or maybe we're just interested in this line, right? And that's where we can mix in some of the customizations that we saw over the last couple of days. So maybe we do a last query user, rep user query. So only show me the line that contains the string stored in this variable. Right, so now I don't get the wtemp start date in my output.
So you're starting to see how we can take all the tools in our toolbox and combine them together in different ways to really help move forward with what we're trying to do. I mean, with just a few lines of code, we've been able to get a date and time, CPU utilization, memory utilization, and to see what root has been doing and what root did in the last command that was inputted into the terminal. But one other thing we might try and do is, what if we wanted to pass a variable into our shell script? So a lot of the commands you see give like a tag and then an argument, or we pass, if we're doing a user add, it requires an argument of what user do we want to add. Change mod, we had to tell it the permissions and the target for those permissions. So we can actually do that within our shell scripting as well.
Yeah, and so I will say that if you want to use options with the hyphens, that can be a lot more complex because there's a shell mechanism called getopt that will get options off the command line. So we're going to avoid that for now. We're just going to pass arguments. So what if I wanted to invoke my script like this? So that instead of having to type in at a prompt the user, I'm providing that as part of my invocation of the shell, and it should just run that command on that user. All right. So
that really helps with longer running commands where you may not need to sit there in front of your desk while the command runs. It's helpful to give that ahead of time and then be able to step away for a bit and then come back.
All right. So what I'm going to do is I'm going to add, and I'm going to do this in a kind of an obtuse way. Actually, you know what? Let's comment out all of our stuff that we put in there for querying that user. And how about we just last $1? You can grab $1.
So you notice before we explain what the $1 is, I wanted to point out that notice that the old code is still there. It's just commented out. This is really helpful if you're troubleshooting or if something's not working right and you want to take a different approach. You can keep that old code there for as long as you'd like, and it really doesn't take up that much space. So you just comment it out. The interpreter will ignore that line, and you can always come back and add that functionality in later, or you can leave comments throughout your code. And one other thing I wanted to mention about the formatting of our script file is notice that the interpreter also ignores blank spaces. So we can format our script file pretty much however we want, adding spaces here, adding comments there, to make it very human readable, but our interpreter is not going to see those new lines any different or those comment lines any different. It's ignored. So it really makes it easier to read through your script or someone else's script to see what they're trying to do.
All right, so I'm going to run this, and then we'll talk about what it's actually doing. All right, so my script, and we're passing an argument. All right, so notice that it still printed out the information about that person being logged in, but it didn't ask me for anything, right? So it turns out that when you pass a script arguments, each one of them is assigned into an automatic variable definition. So the first argument is $1, and the second argument is $2.
What?
And the third argument is $3, and so on, all the way until we've represented all the arguments. And then this guy right here, that's actually $0. So the script name itself, or the program name, is $0. So down here, when I said run based off of $1, $1 is the first argument that was passed to this script. But because we're making that choice based off of the first argument, if you're designing a script that has multiple arguments, now order is important, right? Because this command only runs on that very first argument as its operand. So if you mix up all of your things on the command line, we're going to pull the very first one, even if that's not the one you intended, because you told me in the script, use the first one at this point in our command.
So we're actually going to look, we've got a second episode planned, I believe next week, to go in deeper into shell scripting, and we're going to add in if-then statements and loops. So we could actually, in that episode, we can come back to this example, and we can give it a certain number of times to loop through a process, and that will allow us to handle multiple variables. But stay tuned next week for that one. So Scott, is there any...
A good customization would be maybe we should do both things, right?
Mm-hmm.
Check to see if there's an argument passed, and if so, just use it. But if not, ask us for the thing that is missing. So in that situation, we'll have to use an if statement to check to see what the state of the environment is like, and then choose to either just run last or prompt first and then run last.
So definitely stay tuned next week for that one. And shameless self-plug next week, or I guess it's not a shameless plug, but good information to have. Next week we go to our regular show schedule. So next week we'll be live on Thursdays at 10 a.m. Eastern, and then is it 9 p.m. Eastern for dark mode?
That's correct.
Okay. So yeah, episode tomorrow and dark mode tomorrow, but no episodes on Friday, and then next week we launch into our regular schedule. So I think this is a first for End of the Terminal. We're sitting at 24 minutes, and we got through all of our show notes. Do we want to do another example, Scott? Anything off the top of your head you can think of to share?
Sure, we could do a little bit. I would also leave it open to the live viewers if they have questions, and if you're a deferred viewer, of course, you can put those in the comments of the episode, and Eric and I will get back to them. So I'll do one more example while they're thinking about their questions to ask live. Right, how do we store input from a command? So here what we're doing is we're creating a variable called myUser, and we're assigning into that variable the output from this command whoami. So this $parenthesis syntax says, I want you to run this command and then take the output of this command and do something with it. It's called, running in a subshell, or sometimes you'll see it referred to as quoted execution. And another way we could do the same thing, so I'll comment that out, is this. That's why it's called quoted execution. It uses the back quote. The reason I don't prefer to use back quote is because on some keyboards, specifically international keyboards, that back quote character is really hard to find. So dollar parenthesis tends to be an easier combination for folks that don't use US English keyboards to be able to get access to instead of back quote.
That's a great point. I didn't ever realize that. But for our English using keyboards, yeah, it's also called a backtick or just a tick. If you're looking for that particular key on your keyboard, it usually sits to the left of the one key. And it is kind of a pain to get to, especially if you have small hands.
So I will, down here at the bottom, we're going to print out a blank line, and then we're going to print the content that I stored in that myUser variable, which should be the output of a whoami. All right, so let's see what happens when we run the script. All right, so there's the output of that whoami command that I stored inside of that variable. Now, why this is important is we probably don't want to print it. Maybe we want to do something else with it, right? So let's see.
Well, Scott's typing. Eighth Doctor points out something that I didn't know in the chat here. He said that Bash, more accurately POSIX, deprecated backticks. So now the recommended method is the $ parentheses. So don't worry about backticks. Just use $ parentheses instead.
Okay, so I added a little bit of extra stuff. Notice that you can reference your variable inside of a string that you're wanting to print. So that'll substitute the content of the variable at this point in the output. And then I used it again in a different echo. And then here I'm using it as an argument to a command. So since I'm running the script as root, it should run groups on the root user, and we'll see what happens. Right, so it correctly substitutes here, and then it ran the groups command on the root user and printed the output of that groups command. What we're looking at is a Red Hat Enterprise Linux system, and you'll recall from a previous episode, number 18, where we started with shell scripting, we created a small shell script. So what the script does is it prints out the time, runs a couple of commands to give some system stats, and then will show me the last login of a specific user. And you'll recall that in previous, we could call my script and give it a username, and it would print out this data. Oh, hold on. All right. So what we're going to do in the first couple of minutes of our episode here is we're going to add a if statement to check a condition before it actually executes something. So let me get my last piece of software installed, run it one more time to make sure that we look good. Excellent. All right. So what we did last time was we passed a parameter on the command line to be the argument of the user that we wanted to get the last login information for. And what I've done just recently is I made this little assignment here that says we'll create a variable called user query and we'll assign the thing in argument 1 to that. And previously what we had done is we had moved to passing an argument from asking interactively. And my question is, why not both? Why not use the argument if it's there, or if it's not there, ask interactively? And so to make that decision, we're going to have to add in a statement to check to see if the user has entered an argument or we need to ask. So enter the if statement. So the syntax for if in the bash shell is if, and then we're going to test some criteria. So the open square bracket is a command called test that will resolve the interior of that expression to a true or a false value. And if it's true, we'll do the contents of the if loop. And if it's not true, we'll skip the contents of the if loop. So I'm going to use a command called -z to check to see if something is of 0 length. Okay, so if the user query variable has 0 length, there's no content in it, then we need to do this stuff. And Bash, unlike other interpreted languages, doesn't care about white spaces. However, I make sure that I put my white spaces in there and make it easier to read. And then to close out the if statement, we do a finish if, a fee. So if the variable doesn't have anything in it, then ask the user to input that content and then close. And then we'll go ahead and run our last. So let's try two things. One, does the script still work like it did before? All right, so we successfully get this last bit of data down here if we pass it on the command line. But if I just run my script with no argument, does it then ask me? It looks like it does. Let me see, root. And it prints out the data. And maybe we need to put one more echo statement in there to separate out a little bit. So again, what we did was we checked whether the variable had something in it or not. If it did not have something in it, we asked the question. Or we could be more fancy in that too, and not just check whether the string had nothing in it. We could do something like look to see if that user is listed in the Etsy password file, or do a get ent on that user to see if we can get the entries, and that would hook us into additional authentication sources as well. All right, so the other thing that we could do is maybe instead of one user, we have a whole bunch of users passed on the command line. So how about we change our script one more time, and we will say that a list of users that we're expecting to be passed on the command line are in all the command line arguments. So last time we talked about $1 is the first argument, $2 is the second argument, $3 is the third argument. Well, it turns out that $* is all the arguments, and we expect them to be space separated. So if there's nothing, we'll ask them for a single user. But now, instead of just querying one person with last, we're going to have to do a bunch of people. So for that, we're going to do an iterative loop structure called a for loop. For, and we give it a placeholder variable. I'm going to call mine I in $user query. Do. All right, so let me double check what I'm doing here. So we'll read it. Yeah, okay. So that will work. Okay, and instead of user query, we want to do a last on $I. All right. So what are we looking at here? We've assigned user query to be all the arguments passed in the command line. And then we're going to go through a for loop. And for each one of those arguments, we're going to do a pass through our for loops. We're going to print an empty line, and then we're going to use the last command on that person that we're operating on. And then we're going to move to the next person, print an empty line, run the last command, and then move to the next person until all the command line arguments that have been passed will complete. Now, if I leave it just like this, things are going to work a little bit weird if we don't pass command line arguments. So let me just write this out, and then we'll try the other way and we'll fix it. All right, so if I do a my script on root, RHEL, and Fred. Oh, no, we got a problem there. Line 16, too many arguments. Ah. So my if statement failed because now I have that list of arguments and we're not the right format anymore. So let me temporarily comment this out because we'll fix it. But let me get my for loop going. There we go. So we did our pass for root. The RHEL user hasn't had any logins, so we just get an empty string. And then the Fred user doesn't exist, so we just get an empty string. So that worked correctly. And we can even add maybe an extra thing. Maybe a header that tells us which person we're operating on, so we can actually see that all three of those people are being used. Right? So root, RHEL, and Fred were all parsed. All right, so that's a little bit on if structures and for loops. Let's transition to the second part of the show, and we can take a deeper dive. All right, so the second part of the show is where we take a deeper look into some of these topics. So now we're going to go back into the script, and we're going to make it so the if statement works correctly with the for loop by adding some additional criteria. Also, this is the part of the show where you guys can interact with me via chat. I'll watch that for questions, and I see Shantanu has already asked a couple. And then don't forget to like if you enjoy the content, share it with someone if you think it will help them. Or if you're a deferred viewer, you can interact with us by putting comments on the episode. We'll monitor and respond to those. All right, so Shantanu asks, for multi-Unix scripts, I use the command test, but square bracket for bash. Why not start off with double square brackets? So there are several different ways that one can evaluate something that you're passing to the if command that will return a 0 or a 1, a true or false. Test is one of those commands. Square bracket is one of those commands. Double square bracket, I think, is a mathematic function. So that's why I don't use double squares, because I'm pretty sure that is to do like math resolution. And then Shantanu says that these are the usual bash versus other shell questions. True. So Red Hat Enterprise Linux ships with bash. It does ship with some other shells too, like Corn Shell and Enhanced C Shell or T Shell. But because bash is the default, that's what we're going to cover. Different shells will have slightly different syntaxes. So I try to do stuff that is cross-shell compatible, like square bracket, but I can't try every shell on every platform. All right, so let's go back into our script here, and we'll get this thing working a little bit better. So the problem we saw before the transition was when I did the if statement that I had in there, user query was more than one variable. And so -z saw that there was too many operands being passed to it because it was a space-separated list. So let's see, what could we do to resolve that? Oops. Okay, so if this is, hold on. How about we enclose it in quotes? So that's all seen as a single string. Okay, and then instead of ending our if statement there, we're actually going to come down here. No, that may be enough. Let's see if that works. Okay, so the if statement was skipped over because it was non-zero. Let's try it without the, yep, without an argument, it asks. And then processes are for loop with exactly one person. All right, so what did I do there? One of the things that we haven't talked about a lot in the show is using quotes. So the complaint from -z was that there were multiple space-separated arguments, and -z applies to one argument. So what I did was I enclosed my variable reference in quotes so that it's seen as a single string rather than multiple space-separated strings. And because it's now a single string, -z can evaluate it correctly and see if it's a non-zero string or a zero length string. So that's what was happening there. Maybe in a future episode, when we get even more into scripting, we talk about quotes, because there's 3 types of quotes. There's single quotes, double quotes, and backslashes. And you use each of them in different places. But today was all about ifs and for loops. So let's talk about one other structure for ifs. Okay, so we have an else branch that we can stick in an if. So if the thing that we're testing is false, we'll fall into the else branch. So these are the things that should happen if the user query variable is empty. No user query things were passed on the, sorry, let me try that again. So if user queries were passed on the command line, then we'd fall into this else branch. So how would we just print out a diagnostic message? All right. Okay. So now what will happen is if we pass command line arguments, that causes this to be non-zero or false. And we fall down into this else category, and it will print out the word command line arguments detected, and then we'll hit our for loop down here. If command line arguments are not passed, we'll now have a message that says that we didn't detect any, and then we'll ask the user. And maybe put one more thing in there. Like that. Okay, so let's see if it works. If we pass it without any arguments, right? Command line arguments not detected, asking for username. And then we iterate over that one list of one users and get the last information. If I call it with arguments, right, I get the else section of my if statement executed, and then it goes ahead and prints the iterative results for those 3 past user accounts. All right, how about one other thing? Maybe we should, over here, instead of saying checking for, maybe if it's empty, we should print a message. So this is another place where an if statement might be handy. Okay, so we're going to create a variable called last data. And last data will have that person's last information. And here we're going to say if, again, we're going to use the non-zero or zero. So if it's 0 length, then I'm going to put in an error message and close our if. So now when we run the script for RHEL and Fred users, it should now have this error message that comes up instead of just blank lines. Oh, and something was wrong. Oh, we need an else. So I checked to see whether the last data existed, but then I didn't print it for the root user. So let's throw in an else here. print out that data. Okay, so there's our last information for root, and then we got the error message for these two people. All right, so I'm using 0. There's a analogous, so we could do something like check for non-zero. We could flip the syntax a little bit. So -n says check for non-zero. If it's not 0, then print the last data, else echo the error message. So depending on whether you're checking for a positive or a negative determines which branch we're going to go down. Some other things that I do is I use -e a lot. That is a check to see if a file exists. So if we wanted to maybe open a log file as part of this script, we could do a check to see if the file exists before trying to open it for something. And I'm trying to think of where that's documented. I just opened the man page for Bash. Here we go. Here's a whole bunch of them where it's giving us string comparators or comparators that we can include in our if statements. So earlier we used -z. I just flipped that to a -n. Notice that you can use double equals to say if this value equals this value, or not equals, or less than or greater than. So there's a whole bunch of options that you can use for comparing things together. And this is all documented in the Bash man page. All right. So maybe we want to do, maybe we'll just add in another read real quick and show you an example of that. All right, so I'm asking for a list of files, and then we're going to iterate over that list of files, and we do something like if the file exists, then do a long listing of it. But if the file doesn't exist, we should print out that it doesn't exist. All right, so we have our if, then the stuff that we should do if the if is true, else the things that we should do if the if is false, and then the fee closes out that structure, enclosed within our for loop that starts with a do and ends with a done. All right. I didn't pass a command line argument of list of users, so I'll just put one in. And then it asks me for my list of files. So let's do etc password. Let's do etc shadow. And then one that I know is not going to be there, temp stuffy stuffs. Oh, and then I made the same mistake I did last time, which is not enclosing that string in quotes. No, I think that's right. Oh, let's try it. Etsy password. Let's see, shadow, temp, stuffy stuffs. Oh, and then it didn't aggregate it because I included it as quotes. Yeah. Let's try one more time. Okay, so I got the quoting right. Finally, it works. So we get our listing for Etsy password because that file exists. We get our listing for Etsy shadow because that file exists. And then for temp stuffy stuffs, we fill into that else branch and we get our message that we designed to print out when we fall into the else branch. So we iterated through that entire list. We checked the conditions of something and then we made a decision and executed something based off of that choice. All right, we can also check more than one thing. So you can do conditional execution. We can do something like if this exists and it's readable, then do something. So it turns out that this would cause a problem for us with Etsy Shadow because it does exist, but it's not readable. So we'd probably also have to change our error message here. Or is not readable. So that we can now account in the else statement for both things. Alternatively, we could add in a third thing. Else if. And then we don't need this extra or here. Okay, so if I've done my syntax correctly, so we check whether it's there and readable. If it fails one of those two conditions, we then check to see if it's just readable, which I think we should switch the other way. Because if it doesn't exist, then it may print an error about checking to see if it's readable. All right. So if it is not both things, it checks to see if it exists. If it doesn't exist, try that again. If it does exist, but it's not readable because it failed that first check, then it'll fall into the else. All right, let's try one more time. All right, Etsy password. Etsy shadow. Temp. Stuffy stuffs. Oh, look at that. I've got my logic incorrect, right? Because it's printing errors for both of these, which is what we want, but it's printing the wrong error. So maybe I just have the logic a little bit incorrect. All right, so this is why. Okay. Okay, so let's read this logic one more time. If it both exists and is readable, print the long listing. Fails that, however, we'll check to see if it exists. So that means that it failed the first one, but it is not readable. So we'll print out that it's not readable. And if it neither exists nor is readable, we'll print out that it doesn't exist. Now let's see if that works the way we'd expect. All right, Etsy password. Etsy shadow and temp stuffy stuffs. Okay, so now that you have the logic correct, it prints out the right content. All right.